you see the name Artika, and you know he's the man behind the development of most of this. So thank you all for taking the time to attend. I'll really quickly start the recording, but I wanted to go over what the day is going to be like. So let me
In
get
this
the recording
video, I'll
going.
show you.
This meeting is being recorded.
Okay, so good morning. As I said, my name is Joseph Izerski. I'm joined by my colleague, Principal Engineer Max Artica. Together, he and I will be going over almost everything you wanted to know about deploying multi-site. So it's a technical operations thing that we'll be going through. It is the whole day. It is a lot of information. This is a pilot class for us because it's the first time that we've run this. So the idea here is why are we doing this? Like, what's in it for you? What's in it for us? Kind of thing. And when we look at technologies like multi-site and multipod, today's about multi-site, but you look at those and those are both, valid design choices when you have conditions where a customer has multiple data centers geographically spread apart, and you want to have some sort of logical way to, yeah, deploy, manage, and operate all of this stuff. You can actually run them together, and we'll show a little bit of that today. But ultimately, we wanted to target you as partners, right? um, to pass along, a deeper level of operational knowledge. Because in the work that I do with partners, is we often get questions around theory, like how do I best design this? What are the requirements? How can I solve for this kind of challenge that the customer is throwing at me? So we get questions about theory. How do I design this correctly? But we also get questions around implementation. Is how do I actually implement this correctly? What's the best way to do this? What does a working configuration look like? Now we have, online configuration guides, but those kind of, go through the numbers, but don't necessarily add any color or detail about the why or how. It's just, this is how you configure it. So we want to, give you a bit more deeper knowledge about that. So the focus today will be on multi-site. Like I said, it's like 99% about multi-site today. So the way this is going to go is we're going to have a mix of lecture, and we're going to also have a mix of live lab. So Max, being sort of who I call the podfather, will kind of go over a lot of the concepts, the ideas, the best practices of how this stuff is supposed to work and be designed. And then every module or so, I don't know how long, half hour, 45 minutes, he'll pass over to me, and I have a live lab that I'm actually going to build in front of you, without any safety net, so to speak. And we'll build up a lot of the concepts that Max will present to you in the lecture, so you can see how it works, have at least one example of a running config, I guess you could say, of all of this stuff we're going to talk about. So having said that, it is a lot of information today. We're cramming a lot into one full day. We do appreciate that all day on WebEx can be exhausting for all of us, and us included, you too. So we are going to record this, and we'll stop the video after every sort of lecture lab combo, so that we create a new video file. We will share all of the videos with you. We will share all the slides with you. Basically, anything you see today, probably okay to share with you, right? So don't be afraid to ask if you see something like, oh, you used a script, can I have a copy? Stuff like that. We're glad to share, because ultimately we do this for you so that your knowledge is increased. You can go forth with confidence to propose, design, and install something like multi-site for your customers. And knowing that you're doing it properly, we'll have a better outcome for you, for the customers. For us, it's fewer attack cases, fewer calls for Max for escalations, because he often gets pulled into these kinds of things. So all of our lives will be better by us sharing all this knowledge with you. It is not a basics class, meaning you should already come to this with a working knowledge of ACI concepts. So bridge domains, layer 3 outs, contracts, filters, tenants, VRFs, all that kind of stuff. We're going to assume you know that, because this is really all about how we do it in multi-site, right? So we can answer a few questions, but we don't really have time to go and tell you what a bridge domain is. We assume that you already know that. So I just kind of want to give you fair warning. As I mentioned, this is the first time that Max and I are doing this content in this form factor. So we're not going to be perfect. We'll try our best, but It's likely that I will be making the mistakes, not Max, because I think Max has presented this content at Cisco Live, since like 1952. But in my lab, I might make a mistake. But the thing is, I have Max, I have Conrad, my colleague, with us as a panelist. That you'll keep me on track if I get lost. So we are going to cover as much ground as we possibly can, right? So we're going to cover everything from the basics of setting up the infra, the intersite network, all the way through things like intersite layer 3 outs and service insertion as well. We can't cover 100% of everything multi-site, but we're going to go pretty far into that as well. But there might be some less common things that we decided to cut out because we didn't, quite have time for it. But maybe we'll do this in another day or some other kind of format. We do welcome questions, interruptions, and feedback. There are quite a number of you on the WebEx, which is a good sign for us because it tells us that this is an interesting topic for you too. But please do ask in the Q&A. We'll do the best to answer those questions. We do have someone like Max who has deep, intimate knowledge of these things in the field too. So we can take advantage of that while we have him for the day. So like I said, we'll record everything and we'll share that with you at the end. So really quickly, just an agenda of what we're going to go through. We're in the introduction now and the event flow, but basically we're going to, as I said, go through a series of lecture and then demo, lecture and then demo, lecture and then demo. So this is the general flow. I didn't assign times to them because, well, this is the first time doing it and we'll have to figure that out. But we're going to go through things like intersite design connectivity, how to actually deploy it, what happens now when I bring in things like Multipod into multi-site, backups, migrations. What if I want to update my MSO or migrate it? What do I do? We're going to go through the important, really important topics, the fundamental topics like schemas and templates and how you deploy them in various different scenarios. Then we'll move on to some deeper understanding of what's actually going on in the control and the data plane. And then we'll round out the day showing you how to do layer 3 outs with multi-site, and more importantly, a recent addition, intersite layer 3 outs. And then we'll finish up with service insertion, so service graphs, some east-west firewall stuff in the context of multi-site as well. So the lab we're going to be using today is a lab that I have set up in Amsterdam. This is the topology that I have, and I just want to remind everybody that what you see in my lab is not an example of a production grade deployment. I need to be careful because we see things and we want to copy things, but obviously you can see I'm missing a lot of redundancy in spines and links, IPN devices, all that kind of stuff. It's just a lab, right? It's what I have and it's enough for today, but please don't take this as gospel of this is how you actually build it. This is just enough for us to show you these things in action. Obviously the white papers, the config guides, those are the documents that have the proper production grade way you deploy this thing in terms of devices and links like that. But I can show you everything else, right? I mean, we're not losing anything in the process. And then what I'll do also, as I mentioned, we're going to do multipod with multi-site just to show you that it's possible. So this would be the topology that we're using, and I'll remind you of this along the way so that you know what we're talking about. There's probably more useful material out there than I have links here, but we do have the config guide, which is updated to the latest MSO 3.x. I've got the links here. We have a multi-site Cisco live session from Barcelona, so it's 6 months ago. The link there. Max just did another Cisco live, a digital deployment because of the virus situation, but that's like hot off the press. This is very recent stuff, and you can watch these replay videos and things like that for free. And then, of course, there's always the really nice white paper that Max has written, updated and expanded upon over time, and I've got the latest link here. But if there's one thing I would recommend above all other things around multi-site is read that white paper and understand that white paper, because it probably will answer 90% of your questions there, right? It is a long white paper, but it's technically extremely useful, and so I can't recommend it enough because the info is there for you. And again, it will answer your questions and help you get to the end state much, much quicker. So with that being said, I am going to stop my sharing part and I will pass over to Max. I'll make you presenter and we'll start off with the first session. So I'll keep a track on the clock, Max, so we time it. So.
Thank you, Joe. Maybe you want to address one thing. There were a couple of more questions about the recording, right? Two questions. if and when the recording is going to be provided, and if they can share the recording, right, that is going to be provided. Maybe you can address that while I start sharing.
Yeah, certainly. So ideally, once we end the WebEx event at the end of the day, it takes a few hours for WebEx to do the post-processing, but then our coordinator, Katarina, will send us the links of the recordings today. So ideally, I can share them with you as early as tomorrow, but at the latest, next week, right? So yeah, I'm happy to share them. As far as sharing these videos with others, I don't think there's any top secret information in here. I think this is all publicly known concepts, so I wouldn't have any problem. If you don't have any problem, I don't have any problem. Share them far and
No
wide.
problem.
Yeah, good. Share them far and wide.
Okay, so let's start. Good morning, everybody. I'm also impressed by the large number of people that joined. So, as Joe said, my name is Max Erdic. I'm a principal engineer, part of the Internet-based networking group. I will cover the lecture part of this long day. It's going to be a long day, hopefully not a boring day and hopefully a useful day, but nonetheless, it's going to be a long day. So brace yourself, prepare lots of caffeine. You see here basically the section that we divided our course in, right? So we will cover different topics, and as Joe said, each topic will have a theoretical and lab part. Now, this is true except for the very first part, which is the introduction, which is only lecture, and I'll try to go fast through that, but the important point that I want to cover in the introduction is basically, hold on one second, sorry, is basically make you understand why we did Multipod, why we did Multisite, and why both are still very much relevant, right? So Multisite, this class is focused on Multisite because Multisite is newer, and if you want, as an architecture, is more complex because it puts together different fabric, different epic domains, so there is more technology that we had to implement under the hood to make the experience simple, but the architecture is more complex than Multipod. But the fact that we are Multisite doesn't mean that we forget Multipod, that we don't need Multipod anymore. Okay, so that's at least the point I want to cover, and I want you to get to bring home from this introduction. By the way, Joe, let me know if there is any problem in syncing the slide, because sometimes I have a network connectivity issue, and if that was the case, then I can switch to a faster 4G connection. Okay?
So far we see a blue arrow pointing right.
That's what you're supposed to see. And here, I'm not going to spend too much time here. You can, you look at the recording that Joe said, and, you will find also other sessions that covers this. What you see here is the journey in ACI that we have done from the beginning to today, right? And this is basically, these are all the architecture that are part of the ACI Anywhere umbrella, okay? And so we started with a single pod fabric on the top left. We provided an option to scale up the fabric to build a larger fabric, more resilient with Multipod, right? But still a single fabric, a single epic domain. Then we deploy Multisite, we deliver Multisite as a way to interconnect different fabrics, different networks, different management domains, not only different network domains, okay? And obviously, a fabric in Multisite could be a single pod fabric or a multi-pod fabric. Okay, and that's where the combination of two start making sense, as I will clarify in a few minutes. And after delivering Multipod and Multisite, which really are two architectures that were designed to interconnect physical on-prem data centers, we went to a couple of more architectural options. One is the ACI Remote Leaf, and Remote Leaf, as you may know, we have essentially two flavors: a physical remote leaf, which essentially means taking two or more, one or more pair, if you want, of ACI physical leaf and position them in a remote location, right? So from a management perspective, these physical switches are still managed, are still part of the same epic domain that manages your main ACI fabric, but physically are remotely located, and they connect logically to the spines of your ACI fabric through a generic layer 3 network, right? So the goal is providing ACI connectivity and policy to location in the network where you may not have a need to build a complete leaf spine pod or topology, okay? And that's the idea of physical remote leaf. So we see that used for migration scenarios. We see that used for satellite data center, colo locations. There are different use cases. And then there is the virtual remote leaf, which is also called VPod, which essentially means installing on a computer resources, on hypervisors, a virtual, if you want, ACI leaf, which is basically the Cisco AVE on steroids. So basically, installing AVE on a hypervisor and having that AVE start performing control plane and data plane functions so that they act like a virtual ACI leaf. And that basically allows to extend connectivity or connect virtual machine in a remote location to an ACI environment, even without deploying a single piece of ACI physical hardware in that remote location. Okay, that's the idea of VPod or virtual remote leaf. And again, you can find more information about physical remote leaf or virtual remote leaf. There are white papers about physical remote leaf and VPod that you can search for on Google. But that was the idea basically of another way to extend, if you want, your fabric or your multipod environment, because VPod looks like another pod of a multipod fabric, to different geographic locations. And then the last step is the cloud ACI, which is basically the extension to the public cloud, the hybrid cloud solution, right? And the beauty of the cloud ACI architecture is that it looks very much like Multisite, with the Multisite orchestrator on top that manages different sites. The only difference is that while Multisite is all a physical on-prem data center, with cloud ACI, we have some physical on-prem data center, some public cloud location, right? AWS or Azure. Or you can even have a cloud-first option where MSO manages connectivity between cloud location only, and you don't even have an on-prem physical ACI data center. Some customers start like that to then extend connectivity from the cloud into the on-prem data center, right? Which is the opposite direction that many other customers do, okay? So this is the overall story. The focus today is on Multisite specifically, but essentially how we also relate to Multipod as a way to interconnect on-prem sites, okay? And the question that everybody asks normally is, what should I do, Multipod or Multisite? If I had an euro for every time I addressed the question in the last year, I would be probably millionaire, right? And so what I'm trying to do here is to say, what you need to bring home is the message that they both make sense. They were designed to address different use cases. These may change 1 year from now, right? We may bring new functionality Multisite that allows to address all the possible use cases, and then you will have a single architecture that you can position for everything. That is not the case today, okay? And I don't think that is the plan either, because making Multisite or changing Multisite to address all the use cases that Multipod also is usually positioned for would mean bring way more complexity into the architecture. And that's something that to me makes no sense, okay? We have Multipod, use Multipod or position Multipod for the right use cases, and we have Multisite for other use cases. So what are these use cases? I'm going to skip the terminology, just go straight to the point. In order to understand the positioning, right, high level, we compare what terms that are familiar in AWS environment, in public cloud, like availability zone and regions, with Multipod and Multisite architecture. So when you go to the public cloud, right, and you define in AWS your virtual private cloud, your VPC for resiliency purposes can be deployed across different availability zones, which are all part of the same region, though, right? Your VPC spans the region. It doesn't go across regions. And when you deploy application in the public cloud, or your customers deploy application in the public cloud, they deploy this application inside the VPC usually. And across VPCs, across regions, they do active-active per application deployments or disaster recovery, strategy for the application, etc. But a given application and its component is usually deployed inside a VPC, inside a region. So here we try to position multipod and multisite in the same way. So a pod represents an availability zone if you do this comparison, right? Why? Because it's a physical data center. It runs its own set of control plane, ACI control plane, ISIS, and PBGP, right? Different pods run different control planes. So they're different networks. From a network fault domain perspective, they're different networks under the control of the same epic. So it's the same application policy change domain, the same management domain, but they're different availability zones, right? And you can basically bundle together these pods as part of the same fabric, multi-pod fabric, that becomes your region, okay? Your management domain, which is basically where you extend your layer 2, your layer 3. You don't care about connectivity because multi-pod takes care of that for you, right? If you need layer 2, you have layer 2. If you need layer 3, you have layer 3 by definition, okay? You just need to connect endpoints to the pods, and depending on where, where you connect them, you will have intra-EPG, inter-EPG, intra-BD, inter-BD configuration without having to do anything, right? You manage that like a single pod network. And so you can deploy your application inside that multi-pod fabric inside the region, okay? All the components, you can spread them across. You really treat that multi-pod fabric as a single logical entity, a single logical data center. You can do that many times, right? You can have another region or another set of data centers that you also treat as a multi-pod fabric, right? And you deploy there different instances of applications or completely different applications, right? And then to tie the two together, you can bring multi-site, and you can basically get an inter-region connectivity, which very often only requires layer 3 connectivity. And that basically multi-site allows you to tie together these different regions and create your multi-region environment, right? So from this high-level perspective, right, multi-pod means flexible layer 2, layer 3. Multi-site allows you to do, if you want IP mobility for disaster recovery, you can do it across regions, but mostly it's a layer 3 connectivity between the regions, right? And when I position things like this, right, this is really how the architecture were designed for from the very beginning. But then the question I get is, and let me skip this, is, but wait, I've seen in the past, I read that with multi-site, we can do also layer 2 extension, we can do, so could I use multi-site also for doing that to handle basically use cases like, an application deployment, region deployment that are more typical for multipod? And the answer is yes, you can, right, if you want. So I usually show this slide, and I will talk more about this when we talk about control plane and data plane for ACI. You can deploy multi-site for layer 3 connectivity between the sites, which is what I positioned in the previous slide, which is the use case number 1 on the left here. But you can also deploy multi-site for extending layer 2, to extend the bridge domain between the sites. And when you do that, there are 2 ways of doing that. A better way, a smarter way, a more controlled way, which is use case number 2, where you stretch a bridge domain, but you don't allow the flooding, which is usually the bad part of layer 2 extension, right, to go across the site. So I can still do IP mobility, I can do disaster recovery, I can even do vMotion, right, we'll talk about that, between the sites without extending the flooding. That's the big advantage that ACI multi-site brings you compared to other DCI solutions that are out there in the market, okay? And this is important because if you do that, you have a broadcast storm, you have a problem in that bridge domain in site 1, that problem does not propagate to site 2, which is critical, right? Because if one problem in the data center brings down your multi-site environment, your multi-fabric environment, then you have a bad design in place, okay? However, we support also the use case 3 where, you can extend the bridge domain and allow the flooding as well, right? When would you need that? You would need that when you have a true layer 2 adjacency requirement between endpoints connected to the 2 different fabrics, right? So when they really need to communicate a layer 2, but without even an IP protocol support, right? Layer 2, like layer 2 multicast, layer 2 broadcast, right? There are some old application clusters that communicates like that, right? In that case, you would need to stretch not only the bridge domain, but also the flooding associated to the bridge domain. Is that a good idea for multi-site? In my opinion, is not, because doing that you basically join together the flooding domain between these fabrics. And so you should do that in the context of a region, in the context of multipod, but not in the context of multisite. Multisite should allow you to keep more isolation also from a flooding domain perspective between the sites that are part of the same multisite domain, right? That's what I usually say here is that you should ensure that the bridge domain behavior that you have in your multi-site deployment, 90% of the bridge domain or 95% of the bridge domain behaves like 1 and 2 and not like 3. If the majority of the bridge domain behaves like 3, or if a customer has a requirement to have the majority of bridge domain behaving like 3, you should position multipod for that customer, okay? And maybe the combination of multipod and multi-site, which I showed you before, okay? And additional consideration when you deploy multi-site for use cases that maybe are more multi-pod. One are, for example, when we talk about VMN domain integration. In multi-site, by definition, you are going to end up creating different VMN domain in different sites. Why? Because no matter if you have a single vCenter or one vCenter per site, which is usually the case, you pair with different epic domains, right? So these end up creating different VMN domains, which essentially means some of the functionality that work in a single VMN domain, in a single compute cluster like DRS, vSphere HA, fault tolerance, they do not work with multi-site by definition. You need multipod for that, okay? If you want to have a compute cluster stretch between your data centers and you want to enable these functionalities in the compute cluster, you should deploy multipod. Multi-site does not give you that. As I said, you can still do, sorry, let me go back. You can still do vMotion between sites. You can still do IP mobility, but you cannot enable the functionality that require a single cluster to compute cluster to be stretched across network. Okay, so the use of VMN domain, it's another clear differentiation between the two architecture. The integration of services is another as well, and we will cover that later in the presentation. To finish this introduction, I assume that you know what multi-site is, right? So multi-site looks like what you see on this slide, is interconnecting different epic domain, different fabrics. As I said, each of these sites, each of these fabric could be single pod, could be multi-pod. It does not matter. The key point is that there are three main functional components. One is the fact that we use VXLAN for data plane between the sites, okay? And we will see why that is very important, what kind of information allows us to carry across the site using VXLAN. High level, it allows to abstract the location of endpoints and allows to establish connectivity end-to-end with a consistent policy, no matter where these endpoints are connected. They could be connected to the same top of rack switch. They could be connected to two top of rack switches deployed at the opposite side of the globe. You will have consistent connectivity and consistent policy based on what you configure. Okay? And in order to enable that communication through VXLAN, we need to know where the endpoints are located. And that's where MPBGP VPN comes into the picture, running between the spines of the different fabrics that are part of the multi-site domain and exchanging endpoint reachability information. Okay? These two components, VXLAN and MPBGP VPN, are also used with multipod. I will clarify how specifically I use in multi-site, because the idea with multi-site, we want to give you more control on what type of information you exchange between the sites. We don't want to exchange everything in terms of endpoint. And so we will see how the control plane actually is more, as a more controlled way to exchange endpoint reachability information in multi-site versus multipod. And the third component that we had to introduce in multi-site that we don't have in multipod is the multi-site orchestrator. And we spent a lot of time on the multi-site orchestrator, what it is, why we introduced it, what can be used for, right? But it's something that allows you to get your single pane of glass to manage this multi-network environment, right? Which you didn't need in multipod, since in multipod, that single pane of glass was actually the epic controller itself, because all the pods were under the control of the same epic cluster, okay? Use cases, the not very common, but only with some customers, is scaling up a network in a physical data center location, right? If we have customers that need to build network in a data center with 2,000 top-of-rack switches, there is no way that we can support 2,000 leaf nodes with a single Epic controller cluster, with a single fabric, okay? So the only way to address that magnitude of scale is to break that 2,000 top-of-rack network into different fabrics and interconnect this fabric with multi-site, okay? So that's a typical scale-up use case. The most common for multi-site is obviously the DCI, right? DCI meaning interconnecting data center in different parts of the globe. Not by chance here, you see I have a couple of symbols of routers that represent data center in each geography, because the idea is I will probably use in each geography multipod if my data center are, handled like a single logical data center, metro data center, etc. And then I will use multi-site to interconnect these different locations together and manage them as a whole, right? So DCI is embedded in both multipod and multi-site, right? It's a technology that we have been covering in Cisco for many years, but now we really integrated the DCI function into the architecture itself. So we don't require anymore the deployment of a separate DCI solution like VPLS, OTV, or you name it, okay? Third use case is the extension of the concept of multi-site to interconnect to the public cloud, which is Cloud ACI. And again, there is lots of resources. If you Google it on Cloud ACI, you can find. But the beauty is the architecture will remain essentially the same. So once you understand multi-site, you will understand Cloud ACI very easily. And the last part is the use of multi-site and the multi-site orchestrator also to interconnect a data center through an SR, MPLS, and DOF. This is a very specific use case, a new one, delivered in 501. But it's mostly for service provider, telco, cloud, right? So it's something that we don't spend much time in this training because it's still not a full multi-site use case in my mind, right? It's more a specific market and use case for this customer. They want communication between data center to happen through an SR MPLS enabled network. If you're interested in this specific one, let us know offline and I can point you to more information. With this, Joe, this ends the introduction. So I don't know if you want to stop the recording and then we start. I will continue to go on with the first, actually more technical module, which is the inter-site connectivity deployment consideration. Yeah.
I'll stop now to make a new recording.
Okay.
This meeting is being recorded.
Back to you.
All right. So let's start. And I assume if there are specific questions, Joe, just let me know. Or if you can handle them on the WebEx, on the chat, you don't need to let me know. Let's start with the first technical module about, inter-site connectivity deployment consideration. So we saw in the introduction that multi-site consists in connecting together different fabrics through a network, which is we call it the inter-site network, right? So what we're clarifying here is that what is this inter-site network? What are some of the functionality that are needed from this inter-site network? What are some of the common questions that I always get asked about inter-site network design and connectivity? And I also want to cover some aspects of QoS and a couple of important points about back-to-back topology and cloud-sec support. Okay, so let's start with the functional requirement. The inter-site network, as we said, is the routing domain that interconnects the different sites. Now, depending who you talk to, depending on the customer you're dealing with, that inter-site network could be as simple as a pair of dark fiber, right? That's pretty much the case when they deploy multipod, but there are some customers that also deploy multi-site between two data centers that are not too far apart, just because of the specific use case, and now they want to manage these fabrics. And so this inter-site network could be pair of dark fiber, could be a network that spans across the globe, right? So it could be a combination of private and public networks. So we need to be able to ensure that we don't require too many functionality from that inter-site network, because that would create probably an issue, because we may not have, or a customer may not have a full control of what that inter-site network is, okay? One important point is that the Intersite network is not managed by ACI, not by the Epic, not by the Multisite orchestrator. Okay, so it's used by ACI, but is not managed. Now, that sounds bad, but in reality, what we need for Multisite to work, and the same applies for Multipod, is actually for that Intersite network to be configured day zero initially, and Joe will show you. Once it's configured, Multisite, Intersite communication or interpod communication for Multipod will just work, right? You don't need to touch that external network when you change the ACI configuration. You add a tenant, you remove tenant, you add EPGs, you add BDs, okay? And that's the good news about the fact that it's not a network managed by MSO or by Epic. The topology, as I said, could be arbitrary. The main functional requirement that we have that we require from the network are: point number one, we need to be able to peer with the fabrics, with the different fabrics, and allow exchange of reachability information in the quote-unquote underlay, right? So that I can build then tunnels, fabric to fabrics. These tunnels obviously are always built between tunnel and points, right? Which are loopbacks defined on the spine or on the leaf of the different fabrics. And these tunnels are built into the underlay network domain. So that Intersite network represents an extension of your underlay that you have inside each fabric that allows that TAP information to be propagated across site, and we will see what information is propagated, so that this VXLAN tunnel can be built. But in order to propagate this information, we need to send that information out of each site toward the remote fabrics, okay? And so OSPF is the protocol that we use to basically allow that exchange of TAP or underlay information between each fabric and the Intersite network. And so, two important points. OSPF is the only protocol we support today. So the first Intersite network device that connects to the spines needs to support OSPF, which is quite pervasive, I would say. It's not a big deal. It doesn't mean you need to run OSPF inside the Intersite network. You can redistribute into whatever protocol you want inside the Intersite network. But the first Intersite network device facing the spines needs to run OSPF. Second important point, and this is an implementation specific of ACI, the links from the spine toward the ISN are implemented as sub-interfaces, tagging on VLAN 4, okay? Doesn't mean that they're not layer 3. Functionally, they're layer 3 interfaces, but instead of being a physical layer 3 interface, they're implemented as sub-interfaces, okay? Is that a big deal? It's not, as long as the Intersite network device connecting to the spine supports sub-interfaces and supports the use of VLAN 4, the same VLAN 4 tag, on all the sub-interfaces for all the physical interfaces connecting to the spine. So in this example, you see the ISN on the left connects to 4 spines. I need to support VLAN 4 tagging on the 4 interfaces connected to the 4 spines. So they need to be seen as different layer 3 interfaces. We cannot bridge together the VLAN 4 on the ISN device. That's the important point. 99% of the network device support that, but there are some specific network device, like Huawei, for example, does not support different VLAN, same VLAN tag, on different sub-interfaces and consider them different layer 3 domains, right? So you need to ensure that that is possible, okay? Now, sub-interfaces are only needed on the side facing the spines as well, right? You don't need sub-interface inside the Intersite network, okay? Second point, you may have heard we Multipod, when we need to extend flooding between pods, we need to use multicast in the interpod network device, which is the equivalent, right? The equivalent of the Intersite network for Multipod. We use multicast because with the assumption is in Multipod, the pods are closer to each other. Usually that network is very simple, and deploying multicast, it's a more effective way of propagating that BAM frames across the different pods, right? In Multisite, since the Intersite network could span across the globe, we didn't want to put that requirement or that restriction, right? So we support ingress replication on the spine of the source site every time we need to flood traffic to the remote sites, okay? So that's an important point to understand, so that there is no multicast requirement in the underlay inside the Intersite network, which makes the functionality of the Intersite network easier. What is really critical, though, is that the Intersite network allows traffic to go across, which has a larger MTU than the default 1500 byte IP MTU that normally you have on every interface of every network device. That's what the reason is, because traffic leaving each site has increased MTU compared to the default 1500 byte, and I will cover that in a second, right? So that intersite network needs to allow this larger packet to go across, which essentially means the intersite network devices could fragment and then reassemble the packets before sending to the spines, but we cannot send fragments toward the spine because that will break the connectivity, okay? So if you have a tunnel in the intersite network between intersite network device on the left and on the right, and you fragment and reassemble at the receiving end of the tunnel before ending the packet to the spine, that will work. Or if you can increase the MTU end-to-end across the intersite network, that will work as well, okay? And this point of MTU is quite important, so I usually spend a little bit more time because I want to clarify that there are two aspects of the MTU that you need to consider. There is data plane MTU. So for the data plane communication that goes across sites, right? So this is when you have endpoints connected to the fabric that needs to communicate with each other across sites using the VXLAN encapsulation, right? These endpoints could be physical host, virtual host, external router devices, doesn't matter. Every time the traffic needs to go across, what's going to happen is that every time the packet is received on the leaf, we are going to add a 50 byte VXLAN encapsulation to the packet, right? And that 50 byte is used inside the fabric, but the fabric already takes care of that because we increase the MTU of all the fabric links by default. But the extra 50 bytes are also sent across the intersite network, and that's where the requirement comes. Now, what does it mean that the ISN needs to support 1500 plus 50? It depends, right? If all the endpoints connected to the sites are using the default 1500 byte, then 1550 is all you need. But if you connect some endpoints, like video endpoints, that generate 9,000 byte packets natively, then what you need is not 1550, it's 9,000 plus 50, 9,050, right? So really, the value of MTU that you need to support in the ISN depends directly on the amount on the MTU, the largest MTU generated by the endpoint connected to the fabric themselves. Okay, so it's not 1550. It depends on that from a data plane perspective. In addition to that, there is also control plane traffic that is sent. Right, I told you we established EVPN control peering between the spines in the different fabrics. By default, ACI generates all the control plane packets with a 9,000 byte MTU. So it can generate control plane packets up to 9,000 bytes. Obviously, when you do the establishment of control plane session, you don't use such large packets, but when you exchange information, ACI nodes can use up to 9,000 bytes, which essentially means if you don't do anything, by default, you need at least 9,000 bytes MTU in the ISN, right? Because you cannot fragment, we cannot receive fragment on the spines, and because otherwise you failed basically in exchanging that 9,000 byte packets, but 9,000 byte information. The good news is that this 9,000 byte value, which you see it's a global setting that is 9,000 by default, could be modified. Could be modified at the epic level of each fabric, and you could go as low as you support the value that you support in the ISN. If, for example, to give you an example, your ISN was supporting up to 2,000 bytes only of MTU, you could go to each epic and configure 2,000 for the control plane, so that you will ensure that the EVPN peering would come up and will also be able to exchange information, okay? Remember, the control plane traffic is not VXLAN encapsulated, right? So the number you put here needs to basically match exactly the maximum transmission unit support in the ISN network, okay? So in summary, right, the required MTU that you need in the ISN is a combination of the value that you configure for the control plane, which is under your control or under your customer control, and the data plane maximum size plus 50 generated by the endpoints connected to the fabric. And sometimes the issue of network team is that they're not aware or they don't know what the application team has configured, right? And so they need to basically prepare for the worst, right? And the worst could be 9,000 byte MTU generated by the endpoint, which will require 9,050 bytes of MTU in the intersite network, Okay, so I spend quite a bit of time because this is always asked, right? What is the MTU that I need? And you need to consider these two aspects: the control plane and the data plane. Now, to summarize everything about Internet Network, some FAQ. So, what platform should or could I deploy in the ISN? That I've always been asked this, right? In the Internet Network, do I need a specific router? Well, you need something that can route and can increase, ideally, the MTU on the interfaces. But remember, for the ISN devices facing the spines, you need also support for OSPF, and you need support for sub-interfaces, right? And specifically, sub-interfaces with the same VLAN tag used across all the different interfaces of the same box. Do I need to run layer 3 multicast inside the ISN? We said no, because we're doing this replication. We'll cover this later. Can I use a layer 2 infrastructure as ISN? Okay, well, you can use a layer 2 circuit between ISN devices deployed in different sites, but the connectivity between the spine and the first ISN device needs to be a layer 3 link. Okay, so you could have a VPLS deploy ISN to ISN, but again, spine to ISN needs to be a layer 3 link. So keep that in mind. Do I need to deploy dedicated infrastructure as ISN? Obviously not. That Internet Network could be used for many other purposes. Usually I see customers that share the ISN for multi-site and for other purposes using a dedicated BRF for the ISN traffic, which essentially means the spine interfaces connecting to the ISN router will connect into a VRF, specific VRF, not the default, okay? But obviously that's a network and you can use it for different purposes. Is there a minimum bandwidth that I should deploy between the sites? No, because technically it can work even if you have a 100 gig bandwidth between the sites, but it really depends on how much connectivity you expect to have between the sites. These are always also asked this question, and there is not a magic answer, right? So you could work with 1 gig, you can work with 10 gig. It depends how much bandwidth. The more bandwidth you have, the more bandwidth you can use. Okay, so keep that in mind, and we'll talk about QoS in a second. And is OSPF the only protocol that I can run in the ISN network? And the answer, as I told you, is no. You need to run OSPF between the ISN and the spines, but inside the ISN, you can run whatever protocol you need. And actually, it's a good thing that you normally redistribute between OSPF and another protocol on the ISN devices, because it allows you to control better what type of information you're going to propagate across the site. And we covered that. QoS, right? QoS across sites. In order to understand the point of QoS across sites, we need to refresh 1 second how QoS is handled inside each site. And so, as you may know, in ACI, we support different QoS groups, QoS classes that you see are the one class of services on the left. For traffic that is originated by endpoints or devices connected to the fabric, that traffic can always be mapped to 6 user-level classes, at least from release 4.0.1 and ahead, before there were 3. And so that means that when I receive the traffic, I can say, okay, traffic received on this EPG, or based on a contract, I basically map it to this specific class of services, right? If I don't configure anything, by default, all the external traffic received on ACI goes to the level 3 class, okay? In addition to these 6 classes, we have 4 reserved class of services that are used, you see, for the intra-epic, epic-to-epic controller communication, span, trace route, and the control plane, okay? And how do we identify this traffic inside the fabric? The nodes, the leaf and spine, identify traffic as belonging to one of these different classes based on the cost value and DEI bit values that are in the outer header of each packet that goes inside the fabric, okay? So based on that value, the leaf and spine recognize which class of service the packet belongs to and are able to apply the proper classification, queuing, etc., based on the configuration that you have for each class of service. Now, the problem is we cannot count on this cost and DE bit value to be used in the internet network between the sites. Why? Because, first of all, that these COS and the DEI bits, are part of the .1Q header. And we know that there is a .1Q header between the spine and the ISN because we use sub-interfaces. But inside the ISN, we may not have the .1Q header at all. Okay, and so the COS value and the DEI bit may not be available at all. But the point is, we cannot ensure they are also preserved, right? Even if they are available, we cannot ensure they are preserved end-to-end. So we need a different way to recognize in the InterSite network the traffic belonging to the different classes. And that different way is basically mapping the different class of services that we use inside each fabric to a specific DSCP value, okay? And put that DSCP value in the external header of the packets before the spine send it into the InterSite network. In this example, you see that the user level 1 and 6 to 6, they use CS1, CS2, CS3, blah, blah, blah. That means when user level 1 classes is sent across site, it will be marked with CS1. And why that information is important? For two reasons. Because when I receive the packet on the receiving spine inside 2, I will be able to see at that DSCP value and say, oh, this is CS1. It means when I send it inside the packet, I need to set properly the COS and the EI bit so that that traffic belongs to user level 1. So allows the receiving side to treat the traffic accordingly, right, with the same policy, with the same classification queuing strategy that I had in Site 1. Second, allows also to apply prioritization, classification, and queuing, right, inside the InterSite network by matching on these specific DSCP values, okay? Now, this mapping, DSCP to COS, is still supported only at the epic level, so I need to go on each epic and ensure that I map a consistent values. From release 3.02 of the Multisite Orchestrator, which is coming soon, we will expose that configuration on the Multisite Orchestrator, which makes sense if you think, because I want to be sure that I apply a consistent configuration across all the fabrics that are part of the same multi-site domain, right? So that table will be actually exposed to the Multisite Orchestrator itself, okay? Quickly, last two things I want to cover is for the InterSite network, a specific case of InterSite network is the one where I have dark fibers between the sites, and I want to connect the sites back to back. So basically, the InterSite network disappears in this case, right? We support that. We support with multi-sites, sites being connected back to back. You see here the topology. I know it's maybe not a huge use case for multi-site. It's more a use case for Multipod, and unfortunately, we cannot support it yet for Multipod. I'm not going to go into the why. There is the technical reasons. We are trying to support that by the end of the year, but I cannot promise it's going to happen for Multipod. But for multi-site, we already support this, as long as you do it between only 2 sites. Okay, we cannot support that with more than 2 sites. But if you have 2 sites, 2 fabrics, you can connect them back to back, and the recommendation is to use full mesh, right, just because it simplifies and makes faster failover in case of link or node failure. But we will support also a non-fully mesh topology, okay? Second thing is encryption. One function that sometimes the external network needs to provide between data center is encrypting traffic, right? And this is because of compliance reason, etc. We Multisite, we wanted to ensure that we remove that requirement from the InterSite network, right? And this is possible by using a technology called Cisco CloudSec that essentially allows the spines themselves to encrypt and decrypt traffic when they send and when they receive traffic from the InterSite network, okay? That decryption is performed at the line rate, okay? So there is no performance implication as long as you run this software release 4.01 and this are the release for the spines, right? So FX line cards, if you have a modular spine, or 9332C, 9364C spines, if you run no modular spines. If you have this right version of the hardware and software, you can turn on CloudSec, which is very easy, and all the traffic leaving the spine will be VXLAN encapsulated and also encrypted. You see that we encrypt the payload, the tenant packet, and also the VXLAN header. Obviously, when we do this, we add an additional, I think it's 42 bytes. I documented that in the ACI Multisite white paper. So you need to keep in mind that the packet now is not only that needs to go across the internet network, is not only 50 bytes larger, but 50 bytes plus 42, I believe, or 40, whatever it is, right? So there is an increase overhead because of the additional header, MACsec header that is added to the packet, okay? But this is an easy solution to basically encrypt traffic that goes between the sites. And before you ask, or probably you already asked in the Q&A panel, this is not supported with Multipod, the CloudSec. CloudSec is only supported today between fabrics that are part of a multi-site domain. We don't even support it with the remote leaf yet. It's a roadmap item, okay? With this, I already gave you a lot of information. I'm going to pause and let Joe take over and start showing in practice some of these concepts in his awesome lab. So Joe, back to you.
All right, thank you, Max. All right, let's actually take some of the concepts that Max talked about here and actually show them to you in a working configuration. So in the real world, what does that look like? So let me, Max, if you could make, I'm the host. I can change my role to presenter. I have the power. Okay.
You are powerful.
In my dreams. Okay. So I think what I would like to focus on here in this first demo is looking at the configuration of the intersite network and specifically as it relates to the connection between the spines in a given site to the ISN network, and kind of show you what are the requirements, what does a running configuration look like in the ISN. I'm also going to show you how I set up quality of service across the ISN and what it looks like in ACI, what it looks like across the ISN. And then I will show you CloudSec encryption that Max just talked about as well. I don't have it in my lab, so Max recorded like a 3-minute video because it's not that complicated, and I'll play that video and talk over it. But CloudSec is an interesting possibility when you need to encrypt across the ISN. And the spines, certain ports in the spines, you have to be careful, are set up to do line rate CloudSec encryption, towards and across the ISN. So that's what I'll show in this first demonstration. So like I said, the first thing is let's have a look at what do these links look like between the spines and the ISN devices. So before I go too much further in all of the demos today, in this, let's say, topology that you see here, which isn't exactly my lab, but it's what a production topology should look like, is we're not going to talk about how to install the multi-site orchestrator. It's already installed, but it's not a big deal because it's 3 virtual machines in a cluster. There was some questions in the Q&A about latency. So the multi-site orchestrator is three devices. In this case, they could be virtual machines. And the latency between the MSO cluster members is 150 milliseconds, right? The distance between the MSO itself, the whole cluster, and the APICs that they're managing that you see here, that can be up to 1,000 milliseconds. So the questions that we get is, where do I put the MSO cluster? You can pretty much put it anywhere as long as you have reachability and you're less than 1,000 milliseconds to the APICs that it needs to talk to. Now, what's the latency between sites themselves? So spine to spines across sites, what's the maximum latency? That's 50 milliseconds, right? So be aware of those latency numbers. But we've already got the MSO pre-installed and pre-configured. Like I said, it's not that difficult to install. So I just kind of wanted to let you know, like, where did this MSO come from? It just popped out of the clouds magically. No, it's already set up, and I said it's fairly trivial. So let's go really quickly and look at my connection. So I'm going to focus on a link between one of my spines and my ISN device. And if you remember my lab topology, I only have one spine and one ISN device in each site. So that's easy enough. So let me stop here. Yeah, so that's my topology in reality. So I'll focus on this particular link between spine 1201 and a device that I call IPN West. So let's have a quick look at that. So I need to share that application. So share iTerm, and I will also share Roam. Yeah. Okay, so this is my IPN device. This is the device that's sitting sort of co-resident with Site 1. In my particular case, if you remember, Max said you can pretty much pick any device from any vendor that supports a few basic features. In my case, I've actually chosen a Nexus 92160. It doesn't have to be that. I mean, it's just whatever fits your needs with what you have on hand that has the basic configuration. So the first thing I want to show you is there's certain features that Max mentioned that need to be turned on. So if I show up on features, so remember, we need to be able to support OSPF. Okay, not a big deal. Everybody supports OSPF these days. We need to be able to support PIM BIDR multicast, PIM BIDR specifically. So in this case, I've enabled feature PIM. And really, those are the two main things. You'll see some other features that I have going on here. Those are other things going on in my lab or related to Multipod. But those are the things that are important from a feature perspective. Oh, I'm sorry. You know what? I don't know. Max is shaking his head. I don't need PIM for Multisite. Ignore me. I'm incorrect. I'm getting confused with Multipod. Really, all we need here is OSPF, right? And a larger MTU, right? For to support the VXLAN encapsulation across the ISN. So please don't. I made a mistake there. I don't need PIM for multi-site. We do head-end replication. I'm an idiot. You can agree with me on that one, right? So let's actually go through and look at. I'll show QoS a little bit later, but I've already got it pre-configured. But let's actually go ahead and look at the interface that is connected to my spines here. So I think that is, of course, I have a Mac Butterfly keyboard and it misses characters or repeats characters and it drives me nuts. Okay, so this is the link that's connected from the spine in my site number 1 to this ISN or IPN device called IPN West, right? Notice a couple of things here. I have a higher MTU on the main interface, but really where the configuration sits is on the sub interface, because one of the things that Max talked about is the encapsulation between the spine and the ISN device has to be VLAN 4. It's hard coded. It's VLAN 4. Don't worry if you're using VLAN 4 somewhere else in your data center. This is only locally specific to the link between the spine and the ISN. It's a point-to-point link, right? You don't need to extend this VLAN everywhere. So VLAN 4 is what it is and what it must be. Obviously, I have an IP address, so I just basically set up a /30. This is going to be used for OSPF. So I've configured OSPF as a point-to-point situation, and I've got an OSPF process. I've put this guy in area 0. There's nothing fancy about that. I also use BFD. That's an optional thing, but to me, it's an improvement for some things in case of failure. So I have it turned on, but that's an optional thing. Ignore for now the IP PIM sparse mode. That is related to Multipod, right? And I will show you later on Multipod with Multisite, but I don't want to remove my Multipod config because otherwise it won't work. So please ignore anything PIM related in the context of Multisite. Got it? Okay. So I'm trying to think anything else here. I mean, this is my OSPF configuration here. This is the one here. Basic, as basic as you can get for OSPF. Now, there was a question in the Q&A earlier. Can I use a dedicated VRF across the ISN? Yeah, you absolutely can. In this case, I've done that. It's optional. You don't have to. But I've created a VRF that I call TN-infra. That's just the name that I gave it. Okay, so that is that's my my ISN. It's actually quite simple. It's just basically IP connectivity so that we can bring up OSPF, which is the IGP underlying what we will then use for control plane communication between sites, which is MPBGP. And that's maybe another point to keep in the back of your mind. Whenever we're talking about things like multipod or multi-site or remote leaf, any of that stuff where you're connecting across a wide area network, always keep straight in your head two basic concepts, right? Your control plane protocol will always be MPBGP, full stop, right? Industry standard, it's well known, well understood, scales, multi-tenant, your control plane between these things will always be MPBGP, right? When you want to actually send traffic between sites, right, your data plane is always going to be VXLAN, right? That is your data center interconnect right there. That is a much simpler and graceful data center interconnect. And what we'll show later on is multi-site orchestrator will actually set up that for you. It's actually quite trivial. So that's a basic running config of what my ISN device looks like. I haven't actually set it up. It's not actually working right now. We'll actually do that in a little bit in a future demo here later today. But I think here is like just to have a good working example of what the intersite network running configuration looks like. The next thing that I want to show you is quality of service, right? So if we go back to the image here, is I just mentioned, and I made a big deal of it, that with, we have MPBGP as a control plane, so the spines in each site will actually peer with each other over the ISN to update each other about reachability and endpoints and networks that are in a given site. Because we're going across this intersite network, it's likely a good idea that you apply some sort of quality of service so that we can make sure that control plane traffic is receiving the proper priority. A little bit further down, you might also have certain endpoints or applications that have nothing to do with the spines or anything, but you have tenants and VRFs, bridge domains, EPGs, and let's say down here you have endpoints where you have critical applications, and those critical applications are talking to other endpoints in a different site. And you say, well, I want the application traffic to also receive some sort of treatment or priority quality of service as it crosses the ISN, so it doesn't get starved out potentially by other lower priority traffic that is also crossing the ISN. So I wanted to show you a quick working example of how I've set up quality of service in my particular environment. So the first thing I want to do is I want to go into the APIC. Now, what we're looking at here is the APIC that is managing site 1, the site on the left. I will call that site Amsterdam, whereas site number 2, you'll always hear me call it like Barcelona or site 2. So this is site number 1. And we need to first understand that we have a few things going on. Now, Max already kind of talked about this in this lecture, but we have class of service going on, right? Now, I'm no, queuing master. It's a dark art in my opinion, but if you remember fundamentally, class of service is really a bit that's set in the layer 2 header, right? It's a layer 2 concept, right? And ACI does use class of service, and in fact, it has a default class of service turned on. But when we cross the ISN, we actually need to be crossing a layer 3 network. So we need to take the understanding of how we want to treat our classes of service in ACI and map them to something that's layer 3 aware. And in that case, DSCP markings are markings that are set at the IP layer. So as we're crossing hops, we can maintain and control a prioritization of that traffic using DSCP. So the first thing that we need to do is we need to turn on a mapping between class of service and DSCP in ACI. So, Max talked about this really quickly in his slides as well. So where do I find that in APIC? So here, I'm going to go under the Fabric tab, and I believe it is under Access Policies. So Fabric Access Policies, I think Policies Global, if I remember. Yes, QoS class right there. So if I click on QoS class, you can see those are the default levels that ACI is already setting up for you. Right? I think Max already showed all of this. These are the different levels, right? Yes, sir.
Joe, sorry to interrupt you. Can you zoom in a little bit? Some people have difficulties in looking at the browser. Maybe it would help.
Yeah, I can zoom in a bit, but there is also something that you can do is if you right click on the sharing window and you say show original size or zoom in, you can zoom in yourself. I can try to zoom in, but sometimes when I do that, I run out of space or the thing doesn't render pretty, but I'll do the best I can. But just note that you can always click in the visual sharing panel, right click, and you can see you have your own zoom options, and you can move the screen around and everything. So it's something that a lot of people forget about or didn't know you could do. So you can also use that and together we'll get there. Okay. So I mentioned that we have to turn on this DSCP mappings. Where do we find that? So in this particular case, I'm going to do that under the tenant called infra. Now, this is a tenant that comes, default out of the box installed, right? And we're going to be using tenant infra for a lot of our multi-site interconnectivity needs, right? So if I go under tenant infra and I go under the policies area, and I believe if I remember it's protocol, and I'm clicking too fast. And right here, this is the thing. So it says DSCP class dash COS translation policy for layer 3 traffic. Now I just want to point out that this is disabled by default. So the first thing that you have to do is enable this. So that's actually pretty easy, right? So we'll make that change. So this is going to make that translation. So now what you see below that is how do I want to map my class of service levels that are running in ACI that I just showed you to DSCP markings. You have a choice about how you want to mark the traffic. And then once you make those choices, then you can properly configure your ISN devices to honor and prioritize those markings based on your level. So I'm going to show you really two basic examples, right? So I mentioned before that we have control plane between spines and the sites. And we want to make sure that that control plane traffic, always has enough bandwidth to do what it needs to do. So down here, there is a control plane choices here, and I am going to let's see if I'm going to map this to CS7, right? So this is my choice, right? So I'll show you how that all pans out in the ISN. So that would be for control plane traffic will be marked CS7 DSCP, right? And the second example I talked about is, let's say I have tenant endpoints that need to talk to each other across sites, and they should get some higher level of prioritization. So I'm just gonna pick user level 1, right? And I'm gonna say user level 1. Let's say I have like a mission critical application that just has to get the best priority. So I'm gonna mark that as expedited forwarding, right? Um, so that's a pretty simple set of choices. So when I click submit, I've just now told ACI that as traffic, now this is what's happening. So as traffic is leaving the spine and heading towards the ISN, it will carry these markings so that the ISN can see it. And then I can configure the ISN to say, when you see these DSCP markings, this is the prioritization that these markings should get. Yes. So when we I don't actually have a tenant build, but when we go and we make EPGs at the EPG level, that's where we can set our user levels. So I don't have a tenant handy right now, Bill. I actually kind of cleaned my fabric completely, but you would do this. Let's say let me make a quick EPG and just kind of show you. So if I create an application EPG, right, the QoS class right there. So if let's say in my example, this was the EPG that was going to contain my high priority super critical application, I would just mark it anything level 1. So anything in this EPG will get that QoS class marking, right? Just kind of want to show you where you actually make that mapping to the EPG. So I don't really have EPGs yet, but we'll get there. Okay, so let's really quickly go back to my ISN. I think, did I save? No, I didn't. I need to quickly copy a command. Sorry. Let's have a look at my QoS here, running here. So all I did was I typed show run, and I'm basically saying start here at my quality of service, so it's not so ugly. So if you notice here that I have a class map here, right? I've set up class maps for different levels, right? So there's my control plane mapping, right? So it's saying match on certain DSCP values. And then there was the example for user level 1, match on DSCP 46. Let's just quickly, because QoS, like I said, is kind of a dark art. What does that really mean? So user level 1, if you set it to expedited forwarding actually equals DSCP 46, and CS7 actually matches DSCP 56. So if I go back here, there's my 46 that I'm matching against. there's my 56. Ignore the 32, that's for something else, but I am matching on 56. So once I have my class maps that allow me to look at traffic and match on those markings, now I can go to the next step and say, what do I do with those markings, right? So if you notice here, I created a policy map and I said, any packets that match the class control plane traffic, which is marked as 56, you should set them to quality of service group 7. And any class called user level 1, because you notice these are the names that I gave them, will get QoS group 6, right? So now it's basically saying, match the markings and sort them into these different queues. So now we can go down to the third part down here. So I have my policy map for queuing down here that says for queue number 7, right? This syntax is required, but basically it's telling me queue number 7 matches to QoS group 7, give it priority level 1, right? If it's queue number 6, which is matching here, class user level 1, queue number 6, set it priority level 2, and then for other queues, you can set certain percentages or defaults. I don't go too deep. You can get pretty sophisticated with quality of service, but I just kind of wanted to show you here that what I'm effectively achieving here is I'm saying control plane traffic gets the best treatment always first. And then my supercritical application EPG gets the next level of queuing. Everything else you can do whatever you want, but I just wanted to give you a super simple example about how quality of service is set up. Now, again, my ISN device happens to be a Nexus device. If you chose some other vendor, you would of course have to, figure out how that vendor configures those things. But this is what it looks like using NXOS. So I hope that's clear enough, right? The last thing I wanted to show in this first part of the demo was Max talked about encrypting, right? So CloudSec encryption. So CloudSec encryption is, if you remember, is as packets are leaving the spine, right? They are going to get encrypted. So remember, I keep saying, keep it clear in your mind that two things: control plane is BGP, data plane is VXLAN. So VXLAN is a tunnel, right? Tunnels have endpoints. So as traffic needs to pass through the VXLAN data plane, the spine will encrypt it in this CloudSec and send it fully encrypted across the ISN to be decrypted by the receiving spine. So it's the spines that do that work, right? And as someone in the QA was asking and Conrad answered, um, you need to make sure that the version of the spine that you're using supports MACsec, which I think all of the second generation ones do, but I would just caution you, please always just check the data sheets. But not every port in every model of spine is activated for CloudSec, meaning we might say these 8 ports can do CloudSec, but none of the other ports can. Some spines, all of the ports can do it. Just what I'm saying is it's always good practice, read the data sheet, read the release notes, but the spines are the ones that have the CloudSec encryption capability. Yes? Okay, so because I don't have, I live in Spain, my lab is in Amsterdam, and I don't have the ports connected to my spines that were CloudSec enabled. And Conrad's been bugging me for like a year to go to Amsterdam and change the cable, and I haven't because of the virus and the quarantine. I'm not allowed to go into the office. So Max recorded a quick video, and I need to make sure I'm sharing this. It's really short. It should play well. Let me know if you can see the video. I'll start it now. Everything good? Okay, so it doesn't have any audio, so I have to talk it over it. So what we're seeing here is this is Multisite Orchestrator. Yes, Max has already pre-configured the connectivity across sites, and he's showing that here. So BGP VXLAN as a data plane is already set up, but CloudSec is not enabled. So let me actually go back. Sorry, Max, you're going too fast. So he's basically saying my control plane and data plane between these two sites, Amsterdam and Barcelona, are up and pre-configured. We're going to show you that, don't worry. But for the sake of showing CloudSec, which is what we're doing now, we already have that set up. But he's showing you in MSO that CloudSec encryption is not yet configured, right? So here he's basically saying I've got an endpoint in site 1, an endpoint in site 2, and he's basically saying I'm going to run a ping, and I've got a sniffer sitting in the intersite network, so we can capture this ping in clear text, turn on encryption, and actually show you that encryption is actually working across the intersite network. So yes, I know it's kind of small, but basically he's got pinging right now between endpoint in site 1, endpoint in site 2. Now let's take a look at the sniffer that we've got sitting in the ISN, and it's what the sniffer is actually showing you is, hey, I'm seeing ICMP traffic in clear text at this point in time. It's just proof that that is in fact not yet encrypted. So now let's go back to our Apex. And what Max is going to show you here is, let me pause it, is under tenants, under tenant infra, which is an important tenant when we're talking multi-site, under policies. I know it's hard to see, but there's a policy called CloudSec encryption. What Max has already done is he has created a pre-shared key. It's a trivial thing to do, but for sake of time, he's already created a pre-shared key in site number 1, Amsterdam, and he's already done the same thing in the APIC managing site number 2, Barcelona. Again, under tenant infra, policies, CloudSec encryption, pre-shared key has already been made, right? The config guide tells you how to make it, but it's already done here, right? So now back in Multisite Orchestrator, how do we turn on CloudSec encryption and actually get this working? So what we have here, and you'll see this over again, but we've got our 2 sites connected to MSO. So MSO is aware of the APICs and the sites and everything. So what we're going to do is under the infra configuration. So infra configuration is when MSO goes to set up BGP control plane and VXLAN data plane, it does that for you, and we'll show that to you. But for now, Max is going to make a change to the existing configuration. So he's gone under the site called Amsterdam, and these are the configuration settings in MSO that are related to infra, so control plane and data plane. And it's as simple as turning on the CloudSec encryption button. He's going to do the same thing for Barcelona, turn it on, click deploy at the top, so we actually push the changes. It's important. And now we actually have CloudSec turned on, right? It's actually that easy. Is you've got the pre-shared key, you turn it on MSO, and now we can go back into our overview of the connection, and we can see that MSO is aware and is telling us, yes, CloudSec encryption is on and it is functioning, but we don't trust things. We want to see it happening. So remember our ping. We've still got the ping going between the 2 endpoints across the ISN. So now let's go back to our sniffer and actually see what's going on. And you can see here in the sniffer, in the sort of light blue, that all we see is UDP traffic, right? What is that UDP traffic, this blue stuff down here? Well, that's the VXLAN tunnel traffic, right? All we see are the tunnel endpoints in clear text, but the payload inside of that is fully encrypted, right? So we don't actually see what's in the payload anymore, because that's what we get out of encryption. So that just proves that by turning it on, we're proving our point that CloudSec encryption is in fact working. So back in MSO, if you want to disable that, again, go back into the infra configuration for each of the sites and turn off CloudSec encryption and redeploy, and that will actually turn off CloudSec, and you're back to clear text. And I believe Max will just show you his sniffer again, and yeah, I'm sorry, he'll show you that MSO realizes that CloudSec is turned off, and our pings are still going; they haven't never stopped. And if we look at our final sniffer, there we go. And now we can see here that our ICMP echoes are now once again in clear text, right? So it's pretty easy. Like CloudSec encryption is easy. So this is just to kind of keep in your mind. We support MACsec encryption, which is link to link, physical link from this port to that port. So hop by hop encryption, they call it. But we also support this CloudSec notion. And if you keep it clear in your mind, CloudSec is VTEP to VTEP, so VXLAN tunnel endpoint to VXLAN tunnel endpoint across many hops, right? That's the fundamental difference between MACsec and CloudSec, and we are supporting both. So if you're in a highly secure environment where encryption is important, we have an offering for you, right? The only other thing to keep aware of, and again, Max mentioned it in his lecture, is that there is a small amount of overhead for the CloudSec encryption. Max, I think you said it was like 40, 50 bytes. I don't remember.
I think it's 40 or something. Yes, 40 or something. And Joe, I wanted to interrupt you 1 second because there were lots of questions about CloudSec for Multipod, right? And I wanted to clarify, I said it already during the lecture, but I wanted to clarify, CloudSec for Multipod is not supported today. In order to support it, we need first to remove pin binder. But if you think, right, 90% of the Multipod deployment, even more, are between data centers or pods that are deployed in the same data center or between data centers that are in close proximity with each other. So having dark fiber DWDM circuit is very common. In that case, enabling MaxSec, it's an option. It's an easy option because basically your interpod network is usually built with a couple of devices or maybe 4 devices, 2 in one pod, 2 in the other, right? So you have a limited number of devices that you need to enable MaxSec on, okay? That's an option that I see with Multipod commonly deployed. CloudSec really is important for multi-site because the sites could be geographically separated and normally are geographically separated. But that said, we will look into bringing CloudSec in Multipod in the future, but first we need to remove the dependency from pin binder. Sorry, Joe, go ahead.
Yeah, no problem. No, thanks for that. Yeah, thanks for that. So you're saying you can use MaxSec. Let's say this was Multipod for a second. You're saying MaxSec between here and here, yes? And then a second hop of MaxSec between here and here, and then a third hop between here and here. You're saying that could work? Max?
Yes, correct. Sorry.
Okay. Okay.
Yes, I was on mute.
Okay, yeah, no problem. Okay, so really that's the end of the first demo, right? So basic ISN kind of configuration. So I think now is probably a good time for a break. So let's take 19 minutes and come back at the top of the hour. So 11 a.m. Central European time. We will start again. So I will stop the recording, and we'll come back at 11. Yes. Okay. See you guys, and I'll put up a whiteboard. Okay, it's top of the hour, so let's get started with the next section. But over the break, I forgot one thing I wanted to show you about QoS. It'll take me like 10 seconds, right? So let me start the recording, and then I'll
This
pass to
meeting
Max.
is being recorded.
Okay, before we pass over to Max for the next part of the lecture, with regards to quality of service, I did forget one thing that I wanted to show you, at least in my lab, is I've done all the markings like I showed you, but how do I check? How do I check that the markings are actually being honored or passing? So one of the commands you can do is show queuing interface, and I'm grepping for QoS group 6 because if you remember, group 6 and group 7 were the two priority queues that I was setting. Now, obviously, I haven't sent any packets yet, so the counters are all 0, but this would be the command that you would use where you would see the transmit and unicast and multicast packets here. So if I remember, once we start passing actual traffic, we'll see if my control plane quality of service group is actually working. It should, but just remind me to go and show this again. So with that being said, Max, let me make you the presenter, and we will go on to the next part of the lecture.
All right. So I am the presenter. I need to share. There we go. All right. So we went through the first piece. There was the intersite network, right? And without the intersite network, there is no multisite. So it's quite important to get that in place. And as we said, it's a day zero config. Now, the second component, right, the second part, we introduced the multisite orchestrator. And the multisite orchestrator today is really the main component, right, that allows multisite to work. And we will clarify why the multisite orchestrator is actually critical in the rest of the day. But we will start by discussing the architecture of the multisite orchestrator, and I will clarify, maybe not all of you are aware, that we have today two types of MSO clusters, and I will clarify why and what you should do or what your customer should do going forward. I also will clarify why MSO is different than Epic and how the two actually have complementary functionalities. And then we'll cover a couple of points about interversion support and upgrade procedure. And the upgrade procedure, actually, I won't spend much time because Joe is going to show you. Before going back to the lab, I will also cover how to provision policies on the multisite orchestrator at the high level, because then Joe will show you, but I will clarify what schemas are, templates are, and what usually people do for what concerns the definition of schemas and templates. Okay, so let's start. The multisite orchestrator high level is a cluster of 3 nodes. Okay, this is independent from the type of cluster, from the flavor of cluster that I will cover next. It's a cluster of 3 nodes. 3 nodes that work in active-active fashion, that they sync information between them. And so there is a boundary, a limit of the latency that we can have between the nodes of the same MSO cluster. And that limit is 150 millisecond round trip time, which is quite a good distance. It translates to quite a good distance, but essentially means that it's not a good idea to deploy different nodes of the same multisite orchestrator cluster in different corners of the globes, right? The data centers that are managed by MSO can actually be deployed in the opposite side of the globe because, as you see here, the MSO nodes communicates with the Epic cluster, and that distance, the RTT supported, can be up to 1 second, right? So 1 second, you go around the globe, probably even more than one time, okay? So there is no limit on where you can deploy your fabrics, but the MSO cluster itself should be deployed probably in the same continent, in the same region of the world, right? So that you can satisfy that 150 millisecond requirement. In addition to that, today, we only support communication from the MSO nodes to the out-of-band address of the Epic controller cluster, right? Which essentially means you can connect your MSO nodes wherever you want. They don't need to be connected to the fabric. And actually, majority of customers do not connect the MSO nodes to the fabric. They just connect them either directly to the out-of-band network or to whatever layer 3 infrastructure that allows to have connectivity to the out-of-band address of the Epic clusters. Okay, and the MSO nodes also do not have any layer 2 requirements between them, so they can be deployed in different IP network, right? It's all routed communication, okay, between the node itself and between each node and the IP controller cluster. So bottom line, you have full flexibility on how to deploy these nodes so that you can ensure that this cluster remains healthy, right? So maybe you lose one node because one node goes down, but the chances of losing two nodes at the same time is quite slim because you can connect these nodes wherever you want in your network. However, the usual consideration applies for what concerns the redundancy, right, or the resiliency of the cluster, right? If you lose one node, the cluster remains active. If you lose two nodes, the cluster goes inactive, which essentially means everything you have provisioned will continue to remain provisioned, and every inter-site communication will continue to work, but you will not be able to push new policies until you bring the cluster back to active, in an active state. Okay? Now, this is the same consideration that applies to every database clustering technology. Okay, it's basically a database clustering discussion. In terms of type of MSO cluster, what we have been supporting from the very beginning, from MSO release 101, is a cluster of 3 MSO nodes where each node is a virtual appliance. So you go on cisco.com, you download an OVA, and you deploy that OVA on an ESXi hypervisor. You can have obviously 3 OVAs, 3 virtual machines on the same hypervisor. It's usually a good idea to deploy it across different hypervisors for redundancy's sake, right? But basically, the MSO node itself is a virtual appliance, is a virtual machine. And you cluster these 3 virtual machines together, okay? That builds your MSO cluster. We have been supporting this from the beginning. We still support it, right? And we'll continue to support it for at least the next 6 months. However, we introduced from release 2 to 3 a new flavor of MSO, which is basically working or running on top of a cluster, which is a cluster of the Cisco Application Service Engine. So Cisco Application Service Engine, CASE or SC, depending on who you talk to, they use different names, is the new Cisco compute platform that is deployed for hosting applications. And applications that run on top of the service engine are, for example, the network insights, network insight resources, network insights advisory, the assurance application, network NAE, network assurance engine, right? These are all applications that run on the service engine. MSO, it's another application that can run on top of the service engine, okay? And so what you do in that case, you first build a cluster of, at least in the current implementation, they're still decoupled, right? And I will tell you that we're going to bundle them soon, and I'll tell you when. But for now, you first build a cluster of the service engine. So you build a 3 nodes cluster of the service engine, and then you install application on top of it, like MSO, one example of an application, okay? And this basically opens up different form factors that you essentially can deploy for the multi-site orchestrator, because you can have a cluster of 3 service engines where each service engine is a physical appliance. So you build your physical cluster and then you install the application MSO on top of it. This essentially gives you a physical form factor for the multi-site orchestrator, right? Which some customers have been asking from the very beginning of multi-site. Okay, with the first option that I covered in the previous slide, it's only a virtual form factor available for the first flavor of MSO. Okay, with this, we can have a physical form factor by doing this. Okay, if your customer continues to prefer a virtual form factor, then what we can do, we can build a cluster of service engine by deploying each service engine node as a virtual machine. And here we support 2 types of virtual machine. On top OVA, on top of ESXi host, or on top of KVM, of a KVM hypervisor infrastructure, right? So you have 2 ways, 2 types of virtual machine that we support for service engine. You build your cluster, and then, like you do for the physical cluster, you install the MSO on top. But essentially, the end result is that you have a virtual form factor for the MSO cluster, right? Similar to the original option. Okay. Now, As I said, today we still need to install MSO separately. We are in the next release, we're going to ship a combined OVA, which is basically the service engine and MSO already embedded. So you deploy that OVA and you already have the service engine and MSO together, right? So it's not a two-step operation anymore. Okay. Obviously, when you upgrade, you will upgrade only the MSO at that point, right? But the initial OVA will be a bundle of the two applications, okay? Or actually, of the service engine and of the MSO application. And from Service Engine 1.1.3 release, which is the latest, we can actually run also MSO and other services like Network Insight on the same Service Engine cluster, if you want. My strong recommendation is consider, if you want to have this flavor, right, MSO running on top of the Service Engine, tell your customer to consider that from the Service Engine release 1.1.3 and above. Forget the original 1.1.2. It was the first Service Engine release. Okay. The third flavor that we can do when we run MSO on Service Engine is basically deploying a Service Engine cluster in the public cloud. So you can go and find in AWS, in the market share, I think it's called, a virtual instance, an EC2 instance for Service Engine. So you can build your Service Engine cluster in the public cloud and install MSO, the MSO app on top. Now, one note, currently this is only supported to manage virtual sites, right? To manage basically, you remember when I told you before about Cloud ACI, I told you that MSO can be used to manage public cloud, like if I want to interconnect AWS to Azure and have a consistent policy and connectivity, that MSO can be used for that first only, cloud first, approach. We do not support yet officially running MSO in the public cloud to manage on-prem data center. It boils down to validation. We will do it soon, but it's not supported as of today. Okay, so as of today, for on-prem sites, you have the first two options. Soon will come also the third one. But why we recommend this? For several reasons. Going forward, maybe 6 months from now, we will only continue to support this flavor of the MSO cluster. We will discontinue the original one, right? Because we don't want to have to maintain and test and fix bugs for both flavors, right? So one, this MSO running on SC is going to be the winning proposition going forward. We also have already some new some functionality that are only supported on this flavor of MSO, like for example a GUI upgrade, and Joe will cover that, proxy server configuration, and in the upcoming 3.02 release, I told you about the DHCP mapping configuration is going to be exposed to MSO, and also the integration with SD-WAN. That will only be available with this flavor of MSO. Okay, so if you have customer that new multi-site deployment, position directly this flavor. In terms of license, it's the same license. The cost is essentially the same if you deploy, for example, a virtual form factor, right? So position this. If you have customers that already deployed the other multi-site flavor, the other multi-site orchestrator flavor, at some point suggest that they migrate to this new cluster. And I will cover how the migration can happen in few minutes. Okay, so hopefully this is clear. Okay, let's now move into the comparison between MSO and Epic. As we said, MSO was not supposed to be another Epic or a super Epic, a Uber Epic. Okay, it's something that provides complementary functionality. So Epic remains still the central point of management and configuration for the fabric, right? So the fabric brings up the definition of fabric access policy, the creation of domains, the VMN domain, the physical domain. These are the first three are functionality that most likely will continue to remain only on Epic, because this is something that the fabric administrator does independently from the specific tenant configuration. Okay, what the MSO really is positioned for is for the tenant policies creation. Okay, L3 out today, the L3 out configuration in terms of logical nodes, logical interface is still something that is done at the Epic level. Now we may argue that actually the L3 out configuration is something that is done by each tenant, right? Because you can have an L3 out per VRF and per tenant, and that is the reason why we are also looking into bringing the full L3 out workflow configuration in MSO in a future release. Okay, we haven't done it yet, but we will eventually bring it there. Okay, but for now, also the L3 out is something that remains at the EPIC controller. And obviously, as you know, the EPIC controller cluster does not participate in the fabric control and data planes. You can lose an EPIC controller cluster and your fabric will continue to work. Okay, you cannot make changes, you cannot gather logs or information, statistics, but whatever you provision will continue to work. MSO, as we said, is complementary to EPIC, and the roles of MSO today is twofold. Point number one, the provisioning of the day zero connectivity between sites, right? So the intersite network, we said, is not managed by MSO. Intersite network is configured as Joe showed you at the beginning. What you need to do then through MSO is to connect each site to that intersite network and ensure that these sites can establish an EVPN control plane and a VXLAN data plane. MSO will take care of that, and Joe will show you that in action, okay? So basically the quote-unquote plumbing that you do at the day zero between the sites that are part of the multi-site domain before even considering adding any policy that allows inter-site communication to happen, okay? So that's the first function that it has today. The second one is the creation of the tenant policies, right? So defining, okay, which bridge domain and EPG I want to stretch between sites, or which one I want to make local, but I want to have communication with other EPGs that are local in another site, right? All the inter-site communication needs to be provisioned from the multi-site orchestrator. And I will clarify why that is the case, because that's a very common question that have been asked day in and day out. Should I define the EPG and the BD for this tenant on EPIC or on MSO? The bottom line is every time you want to have an inter-site communication using VXLAN, the policy, the configuration needs to come from the MSO. And to understand that, you will need to understand the concept of shadow objects, and which I will cover in the next lecture, in the next part of this presentation. Okay? We will see in a few minutes that I can also introduce MSO into a brownfield environment, right? You may have already one or more fabrics existing, and I may want to start using multi-site to manage the connectivity between these independent fabrics, right? So I can introduce MSO in a brownfield environment, and I can start importing policies from EPIC or from EPICs into MSO to then allow that inter-site connectivity to be established. And what we're also going to do on MSO is to provide more day two operation functionality, right? End-to-end visibility, troubleshooting functionality, which doesn't mean we're going to implement this functionality into the MSO code itself, because we have this functionality already in product like Network Insights, but we will bundle this product together so that you will have a single pane of glass that will allow you, even in a multi-site environment, to be able to have end-to-end telemetry, end-to-end analytics information, end-to-end troubleshooting, because that's what your customer wants, right? He wants to have a single pane of glass where I can do day zero, day one, day two operations, okay? And MSO, like EPIC, does not participate in the fabric control and data planes, right? So again, you can lose the entire MSO cluster, and actually it's even less impactful, right? Because you will still have the EPIC domain probably learning all the statistics and logs information from each fabric. You will not be able, though, to provision new inter-site policies or establish new inter-site communication until you bring your MSO cluster back to life, right? But it's very seamless, or really, I would say, harmless to lose an MSO cluster in terms of the fabric or inter-site fabric functionalities. Now, one important functionality that we brought into MSO 221, and this is, I harp on this because even if I documented this, we talk about this, it's a point of confusion that many customers still have, is the concept of interversion, right? So before MSO 221, we were dictating that you were running the same release of code on MSO and on the EPIC, meaning the same release, not different software, obviously, but the software that was released at the same time. So if I wanted to run ACI 411, I have to use MSO 211, okay, and so far and so on. And all the sites have to have the same code, which is something that was utterly stupid, okay? Because the key point of multi-site is that I want to be able to connect in the same multi-site domain fabrics that they may be running different releases. And I want to upgrade my fabric at my pace independently from the release I run on the tool that manage this different fabric, which is the multi-site orchestrator, right? And so 2-to-1 finally brought in the coupling of MSO and Epic release. So now you can run whatever MSO release you want as long as it's 2-to-1 and keep the ACI code at the version that you have it. You see, as long as you have a 3-to-6, we don't support software release before 3-to-6 because of some bugs with this interversion logic, right? But as long as you have 3-to-6 or above, you can mix and match the code in your fabrics, and you can upgrade MSO without having to touch your Epic for months or even years, okay? And my recommendation, and I reiterate this every time I talk about this, is always run the latest MSO version available, okay? Whenever it comes out, tell your customer, plan of upgrading because you get more fixes, you get usually more functionalities, and very often the new functionalities are unlocked by simply upgrading the MSO and without requiring to upgrade the Epic software. And one example that we'll talk about is the VZN functionality, right? I will clarify support of VZN for MSO has been released in MSO 2.2.4, and by upgrading to MSO 2.2.4, you can start using VZN in a multi-site deployment without touching any the software on ACI, because VZN in ACI has been supported for a long time. Okay, so always tell your customer to run the latest MSO version available, mostly because it's more robust, more bug fixes, and there is no point in running older versions. Okay, get away from older versions as soon as possible. The reason why we didn't support it before is because we had to build some logic in the multi-site orchestrator to be aware of the different releases that were running in the Epic connected, but more importantly, to know which functionality, which specific functionality is supported in which release, right? Typical example you see here, if I deploy a configuration that requires, that says I want to enable layer 3 multicast, and from MSO I try to push that configuration to a site that runs 3-to-6, right, which didn't support the layer 3 multicast, then I will get, with multi-site, then I will get an error, right? I will get an error when I try to save the template with that configuration, or I will get an error when I try to deploy that template. Okay, the point is the MSO will tell you, I cannot do that. I cannot push this configuration to that site because you don't have the right version of code, right? So this logic had to be built into MSO to allow us for this, okay? And that's why we couldn't support it before 2-to-1, okay? Now, MSO upgrade procedure, 1 second because Joe will cover this. With the new MSO cluster, MSO app running on top of the service engine, we now have a GUI upgrade that looks like this, right? So you can upload an image from a local machine or from using HTTP, and then you just upgrade between MSO releases directly from the GUI. Very nice, very simple, right? Like you are used to do on Epic, okay? No need to do Python scripting or all that crappy procedure that, by the way, I do not recommend anyway. Even if you were to upgrade between MSO releases, right, not running on service engine, I would still recommend to do something like you see here. You have the old MSO cluster, you bring up a new cluster, and you basically export the backup from the old cluster, you import in the new cluster, and you roll back the configuration to the backup file. And from the moment on, you continue to use the new cluster with the multi-site environment. The Epic do not know what MSO is you're using, right? The MSO just does REST API calls to the Epic. So the important point is that you don't use, at the same time, 2 different clusters to make calls to the same Epic domain. Otherwise, you may end up in an inconsistent scenario, right? But this procedure, it's a very common procedure to basically upgrade without going through the Python scripting and stuff like that. It's much simpler. And by the way, it can be used by customers that, for example, run the old cluster, the first flavor, right, the OVA MSO instance cluster, and they want to migrate to the MSO app on top of the service engine, right? They can just move the backup between the first generation cluster to the second generation cluster. Okay? Joe will cover that. Before I give him the ball, few more words about the provisioning of tenant policy on MSO, which is quite important because, as I said, the most important role that MSO has, in addition to creating the day zero control plane and data plane between the sites, is actually pushing tenant policies that unlock inter-site connectivity. Okay, and the important point is that MSO represent the single source of truth for the configuration of the managed tenant, right? Should you manage all the tenants from MSO that you have on Epic? The answer is it depends, right? If a tenant is only deployed in a fabric, you don't need any communication out of the tenant to other tenants or to other sites. You could keep your tenant on Epic, right? But every time you want to establish an inter-tenant connectivity or inter-site connectivity for a tenant, you should manage that from MSO. And the moment you do that, the MSO becomes the single source of truth. So the configuration that you should have on Epic should match the configuration, the intent that you define on the multi-site orchestrator. And the multi-site orchestrator will tell you, will do a drift warning if for some reason some configuration that has been pushed from MSO to Epic is changed at the Epic level. Okay? And I will cover more about this in a second. Okay? Now, the important point is when you go and define your configuration on MSO, we created some hierarchy or a hierarchical object that you can put your configuration, your tenant configuration in. And we have the concept of schemas and templates. So the schema is just a container. It's a drawer where you put your policy in it. The schema contains templates. So the template is really where you define your policy, your configuration with the object that are usually you are familiar with in ACI. EPGs, bridge domain, application network profile, contracts, right? All these objects are defined in one or more templates. And then these templates go inside the schema, okay? And you can have a limited number of templates inside the schema. We'll cover that. And I will cover what is one of the most common approach for the definition of schema and templates. But the first important point to understand is that when you define a configuration in a template, first of all, the template must always be mapped to the tenant. So it's not the schema that is associated to a tenant, it's the template. And I can obviously have more than one template associated to the same tenant, okay? But it is the template that is mapped to the tenant. Point number two, the template is always mapped to one or more sites. So this template, I call it site one template. That gives you a hint that probably I want to use this template to define a configuration that is pushed to a specific site one, to a fabric one, okay? That means I map the template to site one, which means when I say deploy the template, deploy the configuration, that configuration is only pushed to the Epic domain that to the Epic controller that manages site one. It's a one-to-one relationship. But I could also do something different. And then once it's pushed, it is rendered at the Epic level. Right? So I make REST API call to the Epic render the configuration and go configure the ACI leaf and spine nodes to basically realize that intent, right? That desired configuration that I created. I could also do something different. Say I create a template that I call stretch template. I map it to the same tenant, and now I map that template, stretch template, to two sites, site one and site two. Why would I do that? If I want to deploy the same object, the same configuration, across multiple sites at the same time. For example, if I want to stretch an EPG or a bridge domain or a VRF, I want this object to exist in both sites, then I put that configuration as part of the stretch template. But the point to understand is that when I deploy that template, the configuration is going to be pushed at the same time to both Epic domains, okay? I don't have a capability of saying push first to one site and then to the other, right? It's a template. The template is basically, today, the atomic unit of change for the policies, okay, for the configuration. Every change I make in a template, that change is always deployed to the site or the sites that are associated to that template, okay? Now, I can actually deploy templates belonging or map to different tenants in the same schema, as you see here. I have in schema 1, I have a template that maps to tenant 1, and a second template that maps to tenant common. You can do you or your customer can do whatever you want. You can define templates, same schema, templates of different tenants. You can reference objects inside the same schema, across schema. So you have full flexibility. Just a way, schemas and templates is just a way to organize your policies, okay? The important point is that what I see customers usually doing, it's what I show you in the next slide. But the first thing I want to clarify is in terms of scale, right? We have a limited number of templates that we can have in the same schema. And actually that number went to 10 in MSO release 2.4. It was 5 before. So I can have 10 different templates in a given schema. And there is a limited number of objects that I can have in a schema, okay? What is an object? An object is everything I define in a template, an EPG, a bridge domain, a VRF, a contract, right? And if Joe will show you, but when you have your schema, on top, you will have an object counter, right? A policy object counter, whatever it's called, that tells you how many objects you have in the schema. You should keep the number below 500 if you run MSO 2.2 or before, but the number was increased to 1,000 when you go to MSO 2.3 and above, right? So these two number, right, the number of templates per schema and the total number of objects in a schema is what usually drive you into the decision of deploying templates, for a given tenant in a single schema or across multiple schemas. Okay. Now, what I usually see customers doing and what I usually recommend to do is, if you have a scenario like this where you have a multi-site domain with 3 sites, is to go first of all try to bundle together in the same schema the templates that map to the same tenant. Right. So basically, as I said, the schema is not explicitly mapped to a tenant, but if you put in the same schema that all the templates that are mapped to the same tenant, that becomes essentially your tenant schema. Right. This example, I have 4 templates mapped to tenant 1. I put all of them in the same schema. That becomes my schema tenant 1, essentially, effectively. Right. Second point, for each site I have, I normally recommend to deploy at least one template which is site-specific, so that I use to define the object that needs to be deployed only to a given site. So site 1 template, I define object that I only push to site 1. I do the same for site 2 and site 3. And then one or more template that I use for defining the objects that needs to exist in multiple sites at the same time. Typically, the VRF, it's a common object that must exist across all the sites if you want communication for that tenant to happen across the site, okay? The EPG and the BD depends. It depends if they are stretch EPG BDs or not, and we will talk about that during the control plane and data plane session. There are use cases that require to stretch EPG BD. There are use cases that do not, okay? So independently from that, the VRF is usually a common object, and so I associate the common object to all the different sites, okay? And I can get more fancy and say, well, I define a stretch template for object that exists only in site 1 and 2, but not 3, right? So that's why we support up to 10 templates in the same schema, okay? So this is a typical guidelines that many customers use, okay, to define templates and to define policies and to map them to the physical sites that are part of the multi-site domain. We also introduce in 2.1 a capability, which is the capability of migrating objects between templates. For example, let me go back 1 second. Today, that functionality is limited to EPG and BDs, EPG and bridge domains. There are 2 typical use cases, right? Imagine that you had an EPG BD that was associated only to one site because initially you had that EPG and that BD living only in site 1. But now, because of your business requirement, you need to start stretching that EPG to site 2. So maybe initially that EPG and BD pair was associated to a template which only was mapped to site 1 because it was a site local object. Now I want to stretch it. It means I need to take that EPG and BD and move them to a template which is associated to 2 sites, for example, if I want to stretch that EPG and BD across sites. This can be done basically at runtime, right, by moving this object between templates, right? So this is supported in the context of template that belongs to the same tenant, right, from release 2.1. The other use case is the unstretching of objects, right? I had an object that was stretched, maybe because I was migrating an application between Site 1 and Site 2. My migration is completed. I want to remove that EPG-MBD from the original Site 1. I can move basically the EPG-BD pair from the stretch template to a site local template, which is exactly the opposite use case, right? And here you see how basically the GUI looks like, right? You select in which schema you want to move the object and which template. And as I said, the destination template needs to be mapped to the same tenant, right? This is only supported intra-tenant between templates that are mapped to the same tenant. But this is a functionality which could become quite handy. We support it only for EPG-BD. In the future, we may extend to other objects if needed. Okay. The other functionality that we expose is from release 2.3 of MSO, and this is give you an example of why always running the latest MSO, right? Because you see new functionality coming continuously, right? We need to crawl, walk, run as always, right? We cannot deploy everything at once. So in 2.3, we introduce the capability where when you try to push a configuration to a site, a template, you try to deploy a template, we now give you visibility into the specific property that you are changing for each object that is pushed, right? And Joe will show you, this is an example where I changed the contract provided by APG Web, and when you hover with the mouse over modified, it will tell you, okay, when you push deploy, what's going to happen? We are going to add a C1 provider contract to the EPG, okay? You didn't have that visibility in the release before 2.3. You just knew that something was being changed in this object, but you didn't know what, which was a little bit scary, right? Like flying a little bit blind, right? Now we give you full visibility into what specific changes you are pushing where, okay? Last thing I want to cover, defining policies for greenfield deployment is very easy, right? When I say greenfield deployment means I define policy for a tenant that does not exist currently in my site that are part of the multi-site domain. It doesn't mean that there are no other tenants. There may be already other tenants on Epic defined, but the policy for these new tenants are defined. They are brand new greenfield policies, right? In that case, what I do, I start the configuration of the tenant from scratch from the multi-site orchestrator. I divide my policy into templates mapped to multiple sites, templates mapped to the single site, and then I push the configuration to my sites, right? So it's an easy, clean greenfield deployment of policies. Not much to say. One other use case is the one where my tenant may already exist in Site 1. So I already have policies for that tenant that exist in Site 1, and now I added a new site to the multi-site domain, and I want to extend the connectivity for that tenant or the presence of that tenant into a second site. So first thing I do, I extend the tenant presence in Site 2. But then I also need to extend policies. So what I can do, MSO doesn't know anything about the tenant yet, so I import policies for existing policy for the tenant from the Epic Domain 1. So when I say import, I will be shown on the multi-site orchestrator a list of objects, right? That will tell you, okay, these are all the policies that exist on Epic. Which one do you want to import? And I will import policies. Some policies I will import in a template, which is mapped also to Site 2. If I want to start stretching, for example, EPG and BDs across. Some policies I will import into the blue template, which is only local object that continue to stay in Site 1. And then I can create a brand new object for the orange template mapped to Site 2, and then push the configuration down, right? This will ensure that I can start enabling routing connectivity or stretching intra-subnet connectivity between the sites once I push down the configuration. And Joe will show you that. A little bit more complex use case is the one where your customer may already have 2 or more independent fabric running, okay? And maybe these independent fabric are interconnecting using layer 3 only, using the external network through the border leaf, or they also have an OTV, VPLS, an existing DCI connect technology to extend layer 2 between the sites. And now I want to migrate away from that legacy DCI technology and start using multi-site for both layer 2 and layer 3 connectivity between the sites. So in this case, I need to be able to import policies for a tenant. The tenant already exists in both sites. I need to be able to import that policy in MSO, map that policies to the proper template, and then push back the configuration down so that everything continues to be managed for that tenant from MSO. I can do this, right? And if I go back 1 second, the step one, I can do it as long as the policies for the tenant are not defined in a conflicting way across the two Epic domains. For example, if what should represent the same tenant is called like tenant 1 site 1 and tenant 1 site 2 in Epic, then I will not be able to do this because tenant 1 site 1 and tenant 1 site 2, from a point of view of MSO, are two different tenants. MSO doesn't have the capability of merging them together and say, these two, they actually need to represent tenant 1. Okay, that functionality is not there today on the multi-site orchestrator. So as long as these objects are named consistently, not only the tenant, but also EPGs and BDs, for example, that are stretched across the site, you will be able to import them and then start managing, assigning them to the different templates and start managing them from the multi-site orchestrator. Okay, so hopefully this clarifies this brownfield scenario, which is, if you want, a little bit the most complex one that we have. With this, last thing I want to cover actually is scalability. And the only point I want to cover on scale is increasing release after release. You see on the right here the number of scale that we support in 5.0. You need to, if you see or your customer has some requirements, and these are also documented in the scalability guide. If your customer has requirements that that are not met in the current scalability number, please get back to us because we need to know, right? Most of them are just validation. They're not really hard limits, right? So we need to know if we need to increase them, right? And I already mentioned some of the, for example, the increase we did in the latest MSO releases for what concerns the number of schema, the number of objects, etc. We also, last thing I want to cover, we also increased, this is new, so it's important for you to understand. We increased the number of leaf nodes we support in ACI for a single pod fabric. We now support 400 leaves per fabric. It used to be 200, okay? So we increase. So if you need to support 300 leaf nodes in a fabric, you don't need to go anymore for multipod necessarily. You could do that with a single pod fabric. Now, the fact that you could doesn't mean you should, like I always say. It's always good to scale up a fabric with multipod because it separates the control planes across the different pods, etc. But we validated up to 400 leaf in the same pod. In multipod, we also increased the number. They used to be 400, and now it's 500, okay? Now, for what concerns the multi-site deployment, what we do, we support 12 sites, right? The number of leaf you have in each site, and so the total number of leaf in the multi-site domain, it's only dependent on the number of leaf you support in each fabric, okay? So if you run 4 to 4, you can have actually 12 sites with 500 leaf in each because you deploy multipod in each site. So you can have a multi-site domain with 6,000 leaf nodes connected, okay? So there is no limit anymore on the total number of leaf that we support in a multi-site domain. With this, hopefully this was clear, especially the scale angle. Joe, the ball is back to you for lab time part 2.
Very good, Max. Thank you very much. So lots of theory, lots of good theory, best practices. Let me share a few things. Oh, I need to take over role of presenter. And I need to share. Okay. Real quick. Okay. All right, let's get to it. Okay, so what I'm going to show you here in the demo is the different form factors, because I'm actually using both, or I will ultimately use both. I'm starting with the OVA form factor on an older version, 224. I will end up on a completely different MSO cluster running 3.01 on the MSO.ACI form factor. I'll show it to you, don't worry. I'm gonna definitely go through and set up all of the infrastructure. So those links that I talked about, the connection to the ISN, the control plane, the data plane, all of the infra stuff and what that looks like in MSO. I have to say that MSO does a really, really nice job in making that setup of the data center interconnect extremely easy. It's like so simple. You're like, wow, it's like, so I'll show you that. And then I'll talk and I'll show you a little bit about backing up MSO and how I'm going to migrate from one version in form factor to a different version in form factor. And then finally, I'll show you a really quick example about what the GUI UI upgrade procedure is in MSO 3.0 and beyond, right? Because that was one of the features that Max had mentioned. So just to kind of set you up, this is what I have right now. I have 3 virtual machines. So I downloaded the OVA form factor, and this is running 224. I've already deployed those 3 virtual machines. Actually, I'm lying because I only have one single node here, and I wanted to point that out because there is actually a public configuration guide that if it is your lab or proof of concept, i.e. not production, you can get by with a single node MSO. Okay, so I know for you as partners, a lot of times we're resource constrained in the lab. So I just deployed a single node cluster following that config guide, right? But it's the OVA, yeah? And then what I'll do is I also have already installed a newer version of MSO 3.0, but it's the form factor. I call it MSO.ACI because it's the app that I would install on the application services engine. And in my case, I've installed a virtual application services engine, and I've installed MSO on top of that. And just like the OVA for lab and for POC, you can get by with a single node installation, again, just for lab and POC, not for production. And that's exactly what I have. Just because you're partners and you're gonna want to know those answers to the question, right? So I'm gonna start here on the left and then copy my config and show you a migration and an upgrade. Okay, so let's get to the first part, the configuration of the infra stuff in MSO. So this is the setting up of BGP as a control plane. Yes, OSPF and BGP, but BGP is our control plane here. And then the data plane, which is going to be VXLAN. So in order to make that a reality, we need IP addresses. So the first thing we need is we need an EVPN router ID on each of the spines that you want to participate in the connection to the intersite network. The reason why I say want to participate is because it's not required that all spines connect to all IPN devices or ISN devices. You can nominate, let's say, a pair of spines if you wanted. So this is any spine that you want to participate in the passing of traffic across the ISN is going to need an individual and unique EVPN router ID, one per spine. Yeah. So the reason why I make that point is there's a couple more addresses that we need. So we need something called the overlay UTEP address. And this is a single /32 address. It's an Anycast address that simultaneously lives on all of the spines that are participating here and is a single address that represents the tunnel endpoint for unicast traffic, standard data plane unicast traffic packet. So endpoint to endpoint is going to use the tunnel that is bounded by this overlay UTEP or OUTEP, unicast TEP. When it comes to bum traffic, so broadcast unknown unicast and multicast, sort of like flooded traffic, we have a special TEP address, and we call that the OMTEP, right? The overlay multicast TEP, right? And this is, again, a single /32 address that lives on all of the spines. It's any cast, right? And when we have any kind of bum traffic, it's going to use this special tunnel bounded by this TEP address using the OMTEP. Does that make sense? So we just need a single UTEP and a single MTEP per site, which is different because different from the router IDs, which is one per spine. Okay, just wanted to make that clear. So you need to do some planning. You need to pick some IP addresses that you're going to use. So remember, this is my lab setup that we're using for today. So I'm going to basically set up my single spine to a single ISN device and do the same thing on the other side. So looking specifically at site 1, this is pretty easy. We've never done multi-site or multipod or anything before. So we need to have the 4 addresses in red, right? So we need an IP address for OSPF between the spine and IPN. I showed you the IPN side of that, but basically it's like a /30 that I created. We need an EVP and router ID that's going to run as a loopback on the spine. This is going to be the address that we will start our BGP neighbor peering from. Standard routing, nothing fancy here. And then we'll have a multicast overlay tap and a unicast overlay tap, right? Per spine per pod, right? And I'll show you that. Same thing is true for site 2. We've never done multi-site before, so we're going to need to pick addresses that are specific to what's going on in site 2. Yes? So I always find it very useful to have a cheat sheet. So I sit down and I say, okay, I know what I need. Let me pick the addresses that I'm going to use before I start configuring. Because the last thing you want to do is make it up on the fly, because you will not make a mistake, but you'll go, oh, I should have used that subnet, but not this subnet. And oh, no, to make it easier, but just be mindful and plan appropriately. Just make your life easy, right? So here we have site number 1. I have a single pod. I have a single spine, and this is the interface that's connected to the ISN. I picked an address for the OSPF link, the point-to-point link. I've picked a router ID that's unique for site number 1. I've picked a multicast TEP, a unicast overlay TEP and a multicast TEP as well. I've done the same thing for site 2. The reason why I say have this, because MSO is as simple as just copy paste and you hit deploy and you're basically done. Because what is MSO going to do for us? It's going to build the DCI for us. It's going to create all of the config, the layer 3 out. It's going to do everything for us in a really nice and graceful way, right? This is something that I really like. So I'll stop the slides there and I'll actually get to doing it. So you can see my Chrome, right? I think we're good, right? So I have a brand new deployed. Oh, that's the wrong one. This is the one I wanted to show you. This is my OVA on version 224E, right? It's the latest 224, and it's a fresh install. That there's nothing here. Like I literally just installed it yesterday evening, right? So the first thing that we need to do is we need to tell MSO about the sites that we want to participate in our multi-site environment. So it's going to present you with this screen to say add your first site. So the thing here is we need to establish connectivity between MSO and the APICs that are managing a given site. So my first site is going to be Amsterdam, and I'm basically going to give it a URL. This is the APIC. This is the URL of the APIC managing my Amsterdam site. Now it's a lab. I only have one, but ideally in production, well, you must have at least 3 in production. And for those other 2, you would click the plus button and add those other 2. So ultimately, you have all 3 APICs in your environment here. I only have one in the lab, so I only do one. We need to give admin level privileges to MSO to push changes to APIC. Because when we devise policy in MSO and we push it to APIC, obviously MSO needs permissions to be able to do that successfully. So you could create any account with admin privileges. I'm just going to use the admin because that's the default one that I have. Then you need to give it a site ID. A site ID. If it's your first multi-site, just go ahead and pick one. Don't get fancy and start with like 99. If it's your first site, just make it site 1. Less is more, right? So that's as simple as that. So I'm going to go ahead and click save. The next thing, and this is purely optional, but it's going to present me with this sort of stylized map of the globe. And it's basically saying, yeah, if you want, you can drop a visual cue. I need to make sure I don't go too far up. I'm trying to think here. Where is Amsterdam? It doesn't really matter. It's just a joke. I mean, not a joke per se, but it's just a visual approximation that's where Amsterdam is. And I'll say finish. Now, when you see this go green and you start to see information, like it tells me, I know it's hard to see. Let me see if I can, but it tells me that this is good. And as far as health, the version it's running, because remember, Max said we support as of 221 and later, that we support interversions of MSO to whatever's running on APIC, right? So that's looking good. That's pretty easy. Let's do the same thing for site number 2. This is going to be Barcelona. Same process, except there's a different APIC managing site 2, because remember, each site is an independent grouping of spines, leaves, and apex. Right now, they're completely separate entities, right? So this is the APIC managing site number 2. Same kind of thinking. You got to give it the credentials. Hope I typed that right. I don't dare hit the eyeball because then you'll know how to log into my. Okay, and then we need to give it a unique site ID. In this case, I'm just gonna keep it simple and say this is site number 2. And it's like that's the first part, right? We've established, let's say, management plane connectivity between MSO and the APICs in all of the sites that we're done. So did I not? I guess I didn't get to drop the. I have to go down here, right? Because this is where I live now. So Max always says I put Barcelona in the Pyrenees. So I think it's right there. How about that, Max? Okay. So there we go. So we've got our 2 sites added. And that's the first step that we need to do in getting the infrastructure configured, right? So what's the next step, right? The next thing here is, again, still in the Sites tab, we want to click on Configure Infra, right? So here we bring up a new set of configuration examples. The first page is control plane preferences, I'll call them, and there are already defaults set. And the general recommendation here is unless you have a really good reason to change any of these defaults, just leave them as they are, keep it simple. But they are configurable if you desire or need to. But for now, the defaults are good for every multi-site deployment I've ever seen. So if you look to the middle left here, we have a list of sites. Right now we see Amsterdam, we see Barcelona, and they both say disable. So let's go through and enable them. So here I've got the site Amsterdam, but it's important to note that there are nested layers of configuration here. So you see the blue border is around everything in the site. There are certain configurations for site level. If I click on the pod, you see the blue line there is there are certain pod specific level configurations. And then finally, spine level configurations, right? So I click on the spine and you see the configuration pane on the right changes. So we need to do something at all 3 of those layers. So just be aware if it's your first time with MSO, you might have missed that there were layers of configuration. So the first thing we want to do here is actually turn on multi-site. That's the very first thing. Anything in red is something that you as the admin have to input. You will also notice that if there are certain things configured in APIC for site number 1, like my autonomous system number, MSO will import those values, right? It knows that, hey, I talked to APIC and APIC says this is my AS number, so I will import that. And this holds true for other kinds of configuration related to OSPF. Now, I don't have any currently, but if I did, it would present those options. I could reuse OSPF policy if I want. Okay, so the first thing it's asking you for is an overlay multicast tab, right? And if you hover over the little I for information, it says for intersite L2 bum and L3 multicast traffic, yes? And if you remember from my cheat sheet, I have already picked an address right here. I'm just gonna copy it and paste it here, and it's that easy. Down here, it's saying, okay, in order for BGP and all this stuff to work, we need an OSPF connection between the spine and the ISN device, right? So it's going to say, I need some information here because there is nothing currently. So what's your OSPF area? In my lab, if you remember, I chose area 0, right? And my area OSPF area type, we have a choice of not so stubby area or regular. In my case, I have opted for a regular area. I make that choice. This external routed domain. Now, what's happening here is we're going to be creating a layer 3 out in tenant infra. And to satisfy the object model, you should do like the interface policy group, the interface selectors, the leaf profile or the spine profile, blah, blah, blah. And that still holds true. But in the case of multi-site, it is optional because things like VLAN 4 and this is all hard coded. So it's going to work if you don't have an external routed domain. However, if you are OCD like I am, you can go and configure a domain and select it here, right? Multi-site orchestrator would see it and allow you to choose it, right? I just wiped my fabrics last night, so there's basically no config, right? So I don't have any external route domain, so I'm going to leave it blank. Down here, OSPF policies, I'm going to click on it, and I'm going to bring it up because I'm going to use this policy that MSO is building for me by default. Network type is point to point. Don't change any of this stuff. But where I find it useful, and again, these are my personal choices, is I'm using BFD. So I'm going to say, yeah, use it in the layer 3 out. And I always opt for MTU ignore because I always get caught up when one of the things OSPF checks for is does the MTU match between neighbors? And in my case, like one neighbor is 9,000, another neighbor is 9150, this one's 9216. Close enough, right? So I just say MTU ignore. But again, these are optional choices for you, but I wanted to show you that they are in fact possible. You would be unwise to change hello and dead timers, but there they are, and I'm just going to click save. So that is my site level configuration for Amsterdam Site 1. Now I'm going to go down to the pod level. This one's really, really easy. There's just one thing here, at least for now, is the overlay unicast step. And if you remember back from my cheat sheet, I have a unicast step here that I've already chosen ahead of time, so I'm just going to copy it. So paste it there. There we go. That's pretty easy. And then finally, spine level configuration, right? So this is basically saying I need some information about the physical interface on the spine that is connecting to the ISN. Please tell me about it. So we need to go ahead and add port. So I need the port ID, I need an address, I need an MTU, and if I do authentication, that as well. So remember back in my cheat sheet, it's interface 1/20 on the spine, and here's the address that I've already chosen. So what I said, 1/20, there's the IP address. Here, I can specify a number of MTU, or I can just say inherit, whatever's already there. I don't use authentication for OSPF, but you can if you want. I'll click save. So this part is configured, but there's one more little section here that shows up, and that says BGP peering. We definitely want at least one spine to peer with other spines. I only have one spine, so it's important that I turn this on. And if you remember, the third address that I needed was a unique EVPN router ID per spine to establish BGP neighbor adjacencies. So back to my little cheat sheet here, and you can see I've picked a very funny address. I should kind of give you a warning. These addresses that I've chosen, I do not own. Cisco does not necessarily own. I made them up for ease of remembrance, like 111.111. That's obvious. Please, when it comes time to configure your own multi-site in production, please choose IP addresses that you do in fact own and control, because like 11.11.11.20 is owned by the US Department of Defense, and this is never going to be routed in the internet, but it's my lab. But I just wanted to caveat that don't just copy my numbers. Please pick ones that are suitable for your site. I'm just covering my ass there, right? So I'm going to go ahead and paste that router ID in there. There's one more choice here. Spine is a route reflector. What's that all about? Now, in my case, I only have a 2-site multi-site, so I literally already have a full mesh. If you are in a situation where you have a lot of sites, like 4, 5, 6, up to 12 sites, right? It might be computationally wasteful to have all spines in all sites as supporting all these MPBGP neighbor adjacencies. And in order to be potentially more efficient, you have the option to make certain spines as route reflectors, so you can reduce the number of BGP peerings when you have a lot of sites. I only have 2 sites, so it's pointless for me to turn this on, but I wanted to at least point that out. If you have a more higher density number of sites and you want to ease your control plane overhead, right? Make sense? Okay, so that's site 1 actually done. Now I want to point out that I've made all these settings. I've entered data. Has anything been pushed to APIC yet? No, nothing will get pushed until I click that deploy button. Right? So this is building policy, and then when I'm ready, I deploy policy. So keep that in mind. I'm not going to deploy just yet because I want to do Barcelona. It's the same thing. Turn on multi-site. It already knows this is site 2. Going to copy and paste my multicast overlay TEP. So I'm going to go a little faster. Different autonomous system number that it pulled from the Apex managing site 2. OSPF area, again, in my case, I've chosen 0. Regular. I do have a domain in this case. In site number 2, I did configure a domain. And notice it pulled it from Apex, so I can select it here. So that's maybe an example of when you have a domain and you want to clear that fault, but that's optional, right? My OSPF policy is still the same, right? No changes because it's one policy across both. Clicking down to the pod level, my overlay unicast TEP, that is this address here from my cheat sheet. You see, sometimes I click back and forth too quick. So I'm gonna just paste there. That's one single /32 address. Clicking down to the spine in Barcelona. Again, I need to add the port, and I believe I used 1/33 for the spine in site 2. So I'll go ahead and copy that. Is 1/33. Pasting that. Gonna inherit my MTU. Don't care. No authentication. Safe. I am ready to go. Before I do that, I'm in my IPN/IN device that's sitting next to Amsterdam's spine. And I just want to show you my OSPF neighbor adjacencies. This is not something we care about. Please ignore it. It's for something else in my lab. But I just want to show you the current state of OSPF. I don't have anything yet for multi-site. Yes. So I am going to, oh, and then here, I'm going to go into my APIC managing Amsterdam, and I'm going to show you in tenant infra. Make sure I'm in tenant infra. And I'm going to go under the networking tab, and I'm going to open up layer 3 outs, and you see there is nothing there. There's nothing there yet. So let's go here, and we will click the deploy button. Oh, I forgot something. I know you guys were screaming at your muted microphone and say, you forgot your BGP peering. That's good that I did that, because you see MSO does do sanity checking. It says, listen, I'm not going to let you go ahead until we know this configuration is complete and correct. So what is my router ID from my cheat sheet? There it is. Paste it in there. And I turned that one off because I don't need it here in my 2-site deployment. Now I'm ready to deploy, right? So we'll click on deploy. And it's going to take a second or two to push to the apex all of the layer 3 out configuration. And if I go here, what's happening here? What is this guy right here? This 111.111. What is that guy? He's already full. This is the OSPF neighbor adjacency between my ISN and my spine, right? And it's already up and full, right? So we can see here, sometimes I have to hit deploy twice, sometimes when it takes too long, but I'm done with that. So I close that window, right? How do I check? Now, how do I check that my my stuff is actually configured? So I'm going to go to the dashboard here on the left. You notice there's my map. I can hover over my little visual icons of Amsterdam and Barcelona. It actually is pulling any kind of faults. I can click on view connectivity. Oh, that's new. Look at that. It's even animated. Max, I never clicked on it. It's currently not up, and it's currently unencrypted, but let's have a quick look. I'm going to go into this list view, and what's happening here is you want to check this connectivity column, and it says, well, I'm not fully up. I've got a failure with the BGP session. You can click and view the details, and it will tell you. Now, don't get worried about this because it does take a minute or two for all the control plane stuff to come up.
Hey, Joe, can you hear me?
Yes,
Sorry.
sir.
They cannot see the CLI terminal during the demo.
Oh,
I don't know if
okay.
Yeah.
Thank you. Sorry about that. So just for the sake of posterity for the video, what I did was I showed you my OSPF before I deployed MSO. I had an OSPF neighbor adjacency. This is basically my default gateway. It's nothing to do with multi-site. Then what I did was I pushed my MSO config and I showed OSPF neighbor again. And this guy came up right here. This is what is this? The EVPN router ID loopback address of the spine in site 1 doing a peering with my ISN device. That's exactly what I want to see, right? Everything is in order there, so that's good. So so that's good. I hit the refresh button here, and you notice after less than a minute, connectivity is up for both. You want to see both of these green, and you're good to go. Right? You're good to go. So at this point, what do I have? Well, I have basically my data center interconnect is completely set up. My MPBGP control plane is completely set up. My management connectivity between MSO and the apex of the sites that are participating are there and working. It's really that easy. It's MSO to me takes what could be sometimes a complicated config with all these layer 3 outs and just kind of does what needs doing. I like that. So let's have a look at APIC and see what happened. Yeah. So I'm in the APIC for site number 1. And actually, let me refresh because refresh site 2 as well, because I wanted to show you something. Sometimes I have to refresh APIC for this to show, but once I establish that management plane connectivity between MSO and APIC, of course, it's taking forever to load. It should log in. There we go. Notice up here, MSO will push a banner with the site name. This is the site name that I picked in MSO. If I look at Barcelona, it's the same thing, same kind of banner, right? So just to kind of show you. So back under my tenant infra layer 3 outs, what is this? This is the layer 3 out that got pushed by MSO, right? It's done everything for me, right? Everything is looking good. So there's my layer 3 out. I can see, do I have any fault? Nope, no faults. Everything's looking good. Notice a couple of things, and I'll try to zoom in the image. Notice there's like a little extra icon there next to the object for it. This is the layer 3 out called Intersite. That little visual reminder is saying, hey, this was an object that was created and pushed by MSO. Don't touch it here, only touch it in MSO. Just because that's not obvious, we put a text at the top that says, hey, this object here is a multi-site object, only make changes there, right? So just be aware that once you create and push an object from MSO, you want to continue to manage that object and its life cycle in MSO going forward, okay? Let's keep that in mind. So if I look at Barcelona, same kind of thing. So tenants, infra, and here is the site number 2, layer 3 out. There we go. Everything is good. Okay, what do I want to do next? So in my environment, I just did this, yes? And let's say sometime in the future, I come along and I say, wait, did I not? Oh. Sometime in the future, I've decided that I need to scale, and I'm going to make site 1 a multipod site. So remember, I've already got, a multipod. I've got multi-site up and running between site 1 and site 2 right now, at least as far as DCI and management plane goes. And now I want to say, well, I've decided site 1 is going to be a multipod site because I need to scale, or whatever reason is driving multipod. Can I do multipod and multi-site together? The answer is, as of ACI 3.2, you absolutely can. Yes, this is a completely supported, valid option. So let's go do that. Let's actually go and configure this pod 2 and see what it looks like from the point of view of MSO. So where would I do that? So back in MSO, well, actually, no, what I have to do first is MSO only cares about multi-site. It doesn't care about multi-pod. So what I need to do is I need to go into the Apex managing site 1 and set up multi-pod. So this is a little side journey into the multi-pod world. How do I configure that? I'm going to go fast because this is not about multi-pod, but you'll see me do it. So under Fabric Inventory, there's a wizard under Quick Start, and you click on Add Pod. You have a choice of virtual or physical. In this case, I'm doing a physical multi-pod, so I'm going to click on Add Pod. It's going to take me through the wizard to say, listen, you need to establish certain things, blah, 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 blah. If you read this, it's clear. So I'll click on Get Started. Now, here's the thing. Just like multi-site, multi-pod makes use of a layer 3 out between the spine and the interpod network. So you have a couple of questions brewing, so let me answer them. Can the interpod network and the intersite network be the same exact network with the exact same devices doing the double duty? Absolutely, yes, that's possible, and probably the most common thing we see. So the second question you're having is layer 3 out from the spine. Doesn't your spine already have a layer 3 out for multi-site? Yes, it does. Can I reuse that same layer 3 out for multipod and multi-site? You have to, absolutely yes, and that's exactly what we're going to do. So taking me through the wizard, I need to assign a pod number to pod number 2. I need to give it a unique TEP pool. So here's my unique TEP pool. Again, this is sort of multipod basics. I'm gonna kind of go fast. So it's saying the spine or spines, front ending pod 2. What's the spine numbering system that you're going to use? In my case, it's going to be spine 202. It's going to say that spine over there in this remote pod that is now completely unconfigured, undiscovered. Can you please tell me what interface he's using? So I think I have my cheat sheet. Sorry, in a different slide here. Where's my cheat sheet? So just want to point out this is the information that I've set up for the spine in pod 2, site number 1. Are you with me? Right? So it's basically saying which interface. It's going to be 1/20, and which IP address is the next question. So 1/20. There's the IP address, MTU, just leave it as is, and I'll go ahead and click next. So now it's saying I need to bring up OSPF. Yes. I already see that you have OSPF going for multi-site, so I'm going to go ahead and reuse that. But in case you wanted to use a different policy here, no, you don't. Just pick the one that MSO pushed. What does that policy look like? If you remember, BFD, MTU ignore, remember, those were my settings, point to point. My timers were there. So just reuse that policy. We'll click next. The next thing is, this is multipod specific, is we need something called a data plane TEP IP. This is independent of multi-site. This is a special IP for multipod. And in my cheat sheet for multipod with multi-site here, I've already picked a data plane TEP of this address right here for pod number 2. Actually, I should show you both. I picked this one for pod 1, this one for pod 2. I need to set both of those. And this is a /32 Anycast. There we go. So that satisfies there. And then finally, because I'm going to be doing OSPF and MPBGP for multipod purposes, I also need a router ID. And I know you're already thinking, when you get to the multi-site part of this, can I reuse the router ID or does it have to be different? Your choice. You can do either. Okay. So router ID from my cheat sheet, the router ID for the spine in pod 2 is that. So I'll go ahead and copy paste that. There we go. If you leave it blank, if you want to use this as a loopback, that's exactly what I want to do. So I'm good to go. So I'll go ahead and click next. This is all of the objects that the wizard will create. VLAN pools, everything needed to do all this stuff. Notice it's making reuse of the existing layer 3 out called intersite. That's exactly how we want it, right? So I'm going to go ahead and click finish. And this is just basically telling you that we're good to go. You might need to reconnect to APIC. For some reason, the web server needs a service restart. I don't know why. It just is a fact, right? And we're good to go. So I'll say, okay, let me just refresh this just because to get ahead of that. Keep this refreshed because it will log me out over time. Okay. Okay, so you can see there's my pod 2. Of course, now to complete the multi-pod configuration, I need to go and discover those things. So in my nodes pending registration, we see we have a spine waiting. Yes. And I'm going to register that. Make sure we pick pod 2. This guy is spine 202. Give him a name, register. He will discover. And then I have a leaf behind that I will also discover. So what does that look like? It looks like this. So this is what I added right here. The spine, actually it's 1202 by 202, and the leaf behind it 104. This is what I've added, and I've pre-configured this link through the wizard. So when this spine gets discovered, what's happening? This spine right now is sending a DHCP broadcast on VLAN 4. Remember that VLAN 4 hard-coded thing? That's why. We need to know which VLAN to listen for the DHCP broadcast. On IPN East, I have DHCP relay set up. dyslexic. Okay, let me make this larger. This is the link on IPN East, or the one facing Barcelona. Notice I have a DHCP real address. So what's happening is Spine has no config in pod 2. Sends a DHCP broadcast on VLAN 4. This guy who's at the other end of the VLAN 4 link says, I see that, and I'm configured to forward that address as a unicast IP packet over to what? 10.0.0.1. What's 10.0.0.1? It's the APIC managing all of the pods in Site 1. So APIC gets it. APIC now has been pre-configured by the wizard. Let me register this guy as well while we're at it. This is the node 104, E4. APIC has already been pre-configured by the wizard to not only give a DHCP address in return, but also a small XML configuration file that instructs the spine and the remote pod how to bring up OSPF, how to bring up BGP. And through the DHCP exchange, it gets that config file, configures itself, and we join it to the fabric, and we're in business, right? So if we go back over here to registered nodes, we can see there's my second spine in pod 2, there's my leaf 4, finishing up the discovery process, and that's what we want to see. Now, that was my very rapid journey into Multipod, because today's really not about Multipod, but I wanted to set that up sort of after the fact to show you how does this intersect now when I want to do Multipod with Multisite. What are we missing? Well, we go back to my MSO and we go back to my sites. If we go to infra, right, and we click on Amsterdam, where is pod number 2? I don't see it. I don't see it, right? If you click this button, which in future releases we've made much more obvious, but if you click that little button, it's going to refresh. It's going to basically go back to APIC and say, APIC, in regards to infra, has anything changed? Like, have you added anything I should know about? And so I'm going to say yes. And you see, site refreshed, here we go. And all I have to do here is complete the pod 2 overlay unicast step. So if I go back to my cheat sheet, I always forget where's my damn cheat sheet. This one. What's my multi-site overlay multicast step? Well, I'm sorry, my unicast step. I already have the multicast step. It's a single one for the whole site. So I'm going to copy and paste that one. This is the unicast step. Remember the multicast step? That's at the site level, and that's one address for the whole site. Doesn't matter how many pods, in case that was confusing. So I've got my unicast tab here at the pod 2 level, and then down here at the spine. Notice something. Notice what MSO did. It says, I see that it already had a layer 3 out from Multipod, and it's already configured. So it imported that already. I didn't have to configure it like last time. The only thing I need to do here is turn on BGP peering, and I need to pick a router ID. So here I've got a router ID here, right? Go ahead and paste that. Now, before I click deploy, let me set the stage. Something is going to break. It's a bug. I've already filed a bug. It has nothing to do with MSO or multi-site. It's actually a bug in the Multipod wizard. And I will show you how to manually work around it. The reason why I decided to quote unquote open the kimono is because you're partners. And if you run into this bug, I want you to know how to get around it. Okay, so I'm sort of, embarrassingly going to fail my deployment right now. Okay, so when I click deploy, it's going to go out and try to deploy some things, but give it a moment. Notice here, and it's important that MSO tries to tell you when something's wrong, so do pay attention to the visual cues. I've got a red thing here that's standing out. That didn't sound right. Conrad, don't laugh. So it's basically saying, I've got a problem. I couldn't fully push the configuration because the intersite spines are not configured for multipod spines. Spine 201, what's going on there? Let me try to explain this quickly and in not too many detailed terms. So if I go to my tenant infra in site number 1, basically what that error is telling me is Go under the layer 3 out, under my intersite layer 3 out, my logical node profiles here. This is spine in pod 2. He's fully configured, properly configured by the wizard. Here is the spine that's in pod 1, and its configuration was actually pushed by Multisite Orchestrator when we did the first infra configuration like 20 minutes ago, right? What is the problem? Well, here's the way I filed the bug. When you launch this wizard under fabric inventory when we added our pod, it's going to go and check and say, I see that you already have a layer 3 out on that spine, and I'm going to reuse it. Where the bug happens is the wizard incorrectly assumes that the spine in pod 1 is fully configured for everything that Multipod could ever want. And that's not true. It's only configured for what Multisite needs. And that's how it should be, right? Because Multisite Orchestrator only cares about Multisite. It's not going to try to pretend to be anything Multipod. And it shouldn't. That's by design. So what I need to do is I need to manually fix the things that the wizard missed for the spine in pod 1 that it kind of assumed was already pre-configured. I hope that makes sense. Let me go and show you what it missed. Because again, your partners, if you hit this bug in the field, I would rather you fix it in the field than waste the time opening a attack case. I mean, you can always open a attack case, but I want you to know what's going on. So this is kind of, yeah, you got it. So I'm going to go back here. I'm going to go under my logical node profiles here. The first thing that I need to, I'm trying to remember. There were 3 things I needed to change. Let's get them loaded. No, this one's good. I think, yes. Okay, so the first one is under the node spine in pod 1 that was pushed by MSO. You can see here, this object is owned by MSO. Under configured nodes. The first thing I like to do is I like to compare, well, what did the wizard configure for the spine in the second pod? When I click on it, it's like that box is checked. When I click on spine 201, that box is not checked. So that's one thing that's different, right? The second thing down here is external route control peering. If I click here, that box is enabled for the spine in pod 2 that the wizard did right, but it's not enabled for the spine in pod 1. So that's missing. So that's the 2 things I need to change there, right? Now, there's 2 more things I need to change. And it's not actually under the layer 3 out, but it's still under tenant infra, policies, protocol, and there is something called fabric external connection policies. Let me try to zoom in a little bit more if I can. It's this guy right here. So I'm going to open him up. This guy was pushed by MSO, but there's a couple things missing. This, I don't know if I actually have to put a community in because unknown : 0 actually works, but it's red. It's red. So we could choose to do something. Let's be specific and put something in there. So I think that one is optional, but just note that, do something. The next thing is here is enable pod peering profile is off. This should be checked. And if you want to do full mesh or route reflector, depending on how many pods you have, I'll just take the default. It's fine for me, right? Because I only have 2 pods. It's already full mesh, right? I'm going to leave all of that alone. I don't need any kind of passwords. I don't use them. So tick that box. Then finally, further down at the bottom, there's this magical fabric external routing profile. And I know I saw some Dutch partners on the attendee list, and I know you guys have done a lot of Multipod. What's missing here? Well, the subnet is missing for the link between the spine and pod 1, site 1 to the IPN/ISN. And if you don't have that, the 2 pods will never work with each other. Multisite will work just fine because Multisite doesn't care about this setting. Multipod does. So I'm going to go I'm going to go and add the subnet. What is this subnet? It's the /30 between the spine and pod 1 and the ISN or IPN device, right? If it's not in this list, it's kind of like a permit list, right? It basically tells the fabric, these are the addresses that I will allow to establish multi-pod relationships in a simplified manner. So once you do that and close, now you're done. Now let's go back to MSO after all of that, right? I'm gonna refresh because things have changed. Notice I've got a red box around there. Go back here. I have to re-put the TEP pools and stuff like that. So unicast TEP was this guy. I probably could have got away with not refreshing, but just being on the safe side. So we'll redo the config we already did. BGP peering. This one is 222. And, oh, it didn't take that one. Guess I clicked off it too soon. Okay, now the deploy button lights up. We should be good to go now. So let's go ahead and click deploy. And we're good. See, we're good. Okay, so I know I kind of like took extra time for that, but I really want you guys in the field to be confident that you have a fair understanding about what's going on, in this case, this particular bug. Now, hopefully, because I filed this bug earlier this week, it should be fixed relatively soon because I did put a priority on it. Because I don't want you guys to get caught up by all that, but so there you go. That's Multipod with Multisite. That's the configuration. So we can see in going forward, we can deploy policy across pods, across sites. Everything's going to work from the point of view of MSO, and that's what we want. Now, really, really quickly, as I know I'm probably going a little bit longer than I wanted, let me show you a couple of administrative but useful things, right? Because we talked about um, switching form factors and stuff like that, right? So let's minimize this. What did we say? We'll minimize that. We said we were going to do some migrations, right? So let me just kind of set the stage, right? So if you remember, I've done everything on the old cluster. This is an OVA cluster, right? I have a new cluster already installed, pre-installed, different IP addresses, different version of code, different form factor, the MSO to ACI app. What I'm going to do is I'm going to back up the config in the old cluster and save a file locally to my laptop, or you could put it on a web server. I'm going to take that backup file and I'm going to import it into the new cluster, and then I'm going to do what's called a rollback function to activate that config on the new cluster. It's really, really easy to migrate from one cluster to another cluster in this particular method. So let's stop there and go and actually do that, right? So here's my old cluster, just for sake of posterity. This is 224 OVA. I think it's under admin backups. Don't have any backups, so let's go ahead and create my first backup. Call it backup Joe. I don't think you can use dashes. I think it like complains. Yeah, only letters and numbers are permitted. So backup Joe, whatever. You can do local or remote. I'll just go ahead and do it locally for now. Go ahead and click save. You can see this particular backup file has been successfully created locally. You can see there it is. Now what I want to do is I want to grab it and I want to download it, and I'm going to download this locally to my laptop. So you can see down here in the lower left, the backup is now locally on my laptop, right? That's pretty easy. So let's go to my new MSO deployment. This is using the MSO ACI app running on the virtual application services engine. You can see it's version 301, which is the current version. Let me log in. It does have like strong password requirements, and so I have to have a longer password. Someone asked earlier in the Q&A, can we do like integration with Cisco ISE for like TACACS kind of like, or LDAP kind of logins? And absolutely, yes, you can. I have ISE running in my lab, and I have tested it with MSO. It wasn't that hard to set up. There's a config guide, but is it absolutely possible to log in using something like TACACS or LDAP and not just a local account, right? So just wanted to point that out. So if you go under admin authentication, you can do what's called a login domain. First thing I want to point out is the options on the left have changed. Let's look at the old one. These were the options. Let's look at the new one. These are the options. But some of those things like sites and infra are kind of buried in here. Not buried, but reorganized, I guess, is a better word. they're all there. But just wanted to kind of give you the heads up that when you go to 3.0 and later, that we reorganized a little bit of the UI, and so just you might at first be a little bit like, what happened? So the first thing that I want to do here is I want to do backups and restore. So you can see I've already done some backups before, but I just want to show you I don't have anything configured. I have no sites. I have nothing going on, no tenants. That's tenant comment. So I'm going to backup and restore. So what I'm going to do is I'm going to import. I need to select the file from my local machine. So you'll probably see like a gray window, but all I'm doing is selecting the tar.gz file from my local laptop there and saying import. And what it's going to do is it's going to upload that. And we can say, good, successfully imported. That's good. We can see there's backup Joe from today's date. There's my little note. So yeah, I can do. Status is good. So successfully created. What's next? So if I go here, there's these three little dots. Remember I said we had to do the rollback function? This is where we do it. So by clicking on rollback, notice it says this: if the version of the backup is different, and it is different in my case, the rollback could cause removal of features not present in the backup version. That's not really a case when you're going forward to a newer version, but if you were downgrading, that might be a problem. So be aware. And it's basically saying, are you sure? The last thing to point out is this last one. It says, reverting to this backup config needs redeployment of all schemas once again. I don't have any schemas yet, but if I did, I would just have to basically click the deploy button on the schema and it will push those again. Why is that? Because we need this MSO to take ownership of those objects going forward. Because right now they're kind of owned by the old MSO. We need the new MSO to do it. So it's a trivial matter. You just have to deploy again and you're done. So it's not a big deal. So yes, I'm good to go. Rollback in progress. It'll take a minute. Now you're probably asking, what about the IP address of the MSO cluster itself? Does that have to be the same? No, in fact, they should be different because my MSO here is something .220. This one is, I actually had DNS set up, but it's like something like .62. It's something different, right? And that's normal, right? Let's say the cluster level hardware settings like IP address are independent. So the backup should have worked, and I need to log in again because I did back things up and something could have changed with login. So logging in, I just want to show you here that there's my two sites, Amsterdam, Barcelona. There's the infra between them. You can see here connectivity is good. Don't have any schemas. If I go here, this is something new in 3.0, is if you click on infrastructure infra config, you kind of get another table view where you see like connectivity and stuff. But what we do is we show you the configuration, like your overlay multicast tab and is CloudSec on, off, OSPF area ID, all that stuff is there, right? And then in the map view, we added that fancy green line, which means everything is up and working from an infra connectivity between sites. Sound good? Okay, so that's pretty trivial in terms of like backing up something and migrating to a new cluster. Now, the last thing I want to do before lunch is I want to show you how do I upgrade through the UI. So that would be under firmware management. Now, if you remember from the older OVA form factor, so like 2 dot something and beyond, when you wanted to upgrade MSO, you had to download a file from like the basically the code from CCO. You had to manually copy it like SFTP or SCP up into each of the 3 nodes. And then you needed to log into those nodes and kick off a script, a Python script that would go through and unpack and distribute. And it took like 20 minutes or so, right? And you had to like manually log in and kick off Python scripts. That was the old way, right? That was the harder way. We've made it easier. We made it better. So we can do it now in 3.0 and later, because I know someone asked that question. 3.0 and later MSO, we can do it right through the UI. So what you would do is under firmware management, you'd click on add image. You can do a local file from your laptop, or you can have it like on an HTTP or HTTPS server, and it will copy the stuff over, right? I've already done that because we don't want to sit here and watch a spinning ball. So I've already imported. So what would happen is, you see I was running 3.0.099. This was like a beta version. I uploaded 3.01i. It happens to be the current running version, but you can see I already did the upload. When you upload, it takes a minute to unpack. like the files and put them where they need to be. And when it's unpacked, you will see those three little dots. And whatever version you want to go to, you select the version from the list, three dots, and say activate. Now it will take 10 minutes or so to like unpack and copy everything to your cluster and all of that. When it's done, you're going to have to log back in, but you will see a status of running. Let me show you how to check from the CLI if you're troubleshooting, because you're partners. So damn it. So sorry, I need to. Sorry about this. Need to just modify the file. Ignore what I'm doing now. This is just stupid laptop admin so that I could SSH. Oh, really? Did I not? I guess I didn't right quit. Yes, that's what I wanted. I think, what did I use for this one? No, what's going on? God, I forgot my password.
Nobody can help you with that.
Yeah, but the command you would type is this, ACI.health. And if it was working, you would hit enter and it would tell you what the status was. So sorry, demo gods hated me for that one. I haven't logged into the CLI in a while, so I apologize. But that's the command, ACI.health. And I think I remember what it was. I think, Max, what you're trying to tell me is it's root. No. Screw it. I'm not going to waste any time. Sorry about that. But that's the command. I would log in as root. Somehow I've forgotten my root password. Oh, big deal. I still have access to the UI. Okay. I think that covers everything I wanted to cover in this part of the demo. Max, did I miss anything before I stop the
think it was
recording?
pretty comprehensive. No, I think we're good.
Okay, so I'll stop the recording. What we're going to do, Max, I think because you talked about tenants and schemas, after lunch, you want me to just go right back into the demo, right? Or did you want to do more lecture?
No, I've done the lecture also for that, actually. And so do the whole thing. Yeah.
Okay, so what we will do here is let's take 47 minutes for lunch and come back at 13:30 Central European time. I'll put a whiteboard up. So 13:30, so about 47 minutes from now, we'll resume with the next set of the demos, okay?
All right. Enjoy your lunch, guys.